dear students, Namaste. Welcome to ACE Engineering Academy and ACE online platform. Students, on 19th January 2025, we have conducted a pre-GATE examination 2025 for the aspirants who are appearing for GATE 2025. And as per the standards of GATE, we prepared the question paper and it must be always under jumbling order. I hope you guys knows that. For example, let me say the first question you may get from electronic devices, second question may be from analog electronic circuits, third question may be from digital, fourth may be again electronic devices, fifth may be from network analysis in that way. Whereas in this video, we have given you the solutions, the video solutions for the pre-GATE 2025 in a subject-wise order. Okay, it is not jumbling, pattern. We have given order-wise video solutions, by which I believe that will get a good benefit for the students who are concentrating on the tricks what we have exposed for the questions. And also, my dear students, based on the request of multiple students, throughout the country to the ACE management, we decided to conduct one more free mock test online examination, on 26 January 2025. For credible information regarding this exam, the details, you can just go with the QR code what is disclosed onto the screen. Just scan it, you will be getting a detailed information about that. And from morning 9 a.m., 9:30 a.m. to 12:30 p.m., we are conducting for the papers of civil engineering, mechanical engineering, instrumentation, data sciences and artificial intelligence. Whereas for electronics and communication, electrical engineering, production engineering, computer science and information technology papers, we are conducting this exam from 2:30 p.m. to 5:30 p.m. But don't forget guys, the last date to apply for this exam is 24th January 2025. The main advantage of writing this exam is you can boost up the confidence, which is very important, because the students who are appearing for the GATE 2025, you need some sort of motivation, you need some sort of practice, correct or not? You must be having some credible information how to manage the timing, how to use the calculators in a proper way in the examination. For that purpose, I appeal everybody, who are watching this video, apply for this exam, go for that exam and just kickstart for a beautiful career. And best wishes from ACE Engineering Academy for the GATE 2025.
Hi, I am going to discuss the control systems pre-GATE questions. So, first one, the block diagram of the control system is shown in figure. The transfer function C of S by R of S is. So, C of S by R of S equal to. So, here there are two forward paths are there. One forward path is straight like this, and second forward path is through 1. And there are 4 loops are there. Here this feedback path 4 gives the loop 1 and as well as loop 2. Then this unity feedback gives loop 3, loop 4. So, write the first forward path again. What is the first forward path again? 1 by S into 3 by 3S. 1 by S into 3S is the first forward path. To this, all the loops touching. Plus second forward path. What is the second forward path? Second forward path is here 3 by S. 3S. Second forward path. Yes or no? 1 into 3S. 3S divided by loops 1 plus opposite sign of first loop gain 4 by S, opposite sign of second loop gain plus 4, opposite sign of third loop gain. Third loop gain is what? 1 by S into 3S means, so SS cancel means plus 3. Opposite sign of fourth loop gain like this. So, what is the fourth loop gain here? Plus 3S. 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 Then simplify this. What you are getting? SS cancel. Here you will get 3 plus here 3S divided by. If you take LCM here, it will become 3S square plus here it will become S plus 4S plus 3S plus 4. 3S plus 4. Yes or no? So, then this S goes to the numerator and into S. Then if you solve this, what you are getting? 3S, take it common. then you will get what? S plus 1 divided by denominator 3s square plus 3s square plus bolo here 3s square plus here 3s 4s plus 8s plus 4. So the answer is what? 3s into s plus 1 by 3s square plus 8s plus 4. So it is answer D. The answer is D. Next. So here a linear time invariant system characterized by homogeneous state equation given state transition matrix is. So you have to find the what? STM. You need to find the STM. So find first you write it Si minus A. You write it Si minus A. So first write STM you have to find. Solution. STM you have to find. So what is the formula? Pi of t equal to what? E power at. That equal to what? Laplace inverse of Si minus A inverse. That equal to Laplace inverse of adjoint of Si minus A divided by what? Det of Si minus A. Det of Si minus A. First write it what? Si minus A. First write Si minus A. So if you write Si minus A, so add S diagonally, na? You should add S diagonally. Opposite sign of coefficients if you write. First one what is there? 0, minus 1. So here 0, here minus 1, here it is what? Here it is plus 1 plus 2. So that means 1, here it is plus 2. This is what? Si minus A. Adjoint you write, adjoint of Si minus A. Adjoint of Si minus A if write. So what you will get here? Tell S plus 2, here plus 1, here minus 1, here yes. Here yes. So now find the STM. So pi of t equal to Laplace inverse of, so here adjoint S plus 2, here 1, here minus 1, here it is S divided by det. What is det you are getting? S square plus 2S plus 1. S square plus 2S plus 1 divided by S square plus 2S plus 1. S square plus 2S plus 1. So then you write inverse Laplace transform apply, L inverse of, what I can write here? S plus 1 we can write denominator, S plus 1 whole square. Here we can write 1 by S plus 1 whole square. Here you can write minus 1 by S plus 1 whole square. Here you can add plus 1 and minus 1 divided by what? S plus 1 whole square. Apply inverse Laplace transform. You will get the answer is what? Here you will get the answer t, I will write it 1 plus t into e power minus t, t e power minus t. Then here minus t e power minus t. Here 1 minus t e power minus t. This is the answer. That means what is the answer here you are getting? I think answer is C. Answer is C. Next. So the open loop transfer function of a unity feedback system given, critical damped dimension, steady state error 0.5 given, the value of k and tau r. So here first find closed loop transfer function. First find closed loop transfer function. What is the closed loop transfer function? K by S square tau plus S plus K. Divide with tau. Then what I am getting? K by tau divided by S square plus S by tau plus K by tau. Compare with standard form. Compare with standard form. What is the standard form of second order system? Omega n square by S square plus 2 zeta omega ns plus omega n square. Compare these two. Get it omega n. What is omega n? Tell. Omega n equal to root of k by tau. Root of k by tau radians per second. So 2 zeta omega n equal to what? 2 zeta omega n equal to what? 1 by tau. 1 by tau. 1 by tau. 2 zeta omega n equal to 1 by tau. So now zeta is given here. Is given zeta. Read the question. Critical damped. System is critical damped mentioned. That means what is zeta 10? Zeta equal to 1. So that means what you are writing? 2 into 1 into omega n equal to 1 by tau. So what is omega n? Tell. Come on. 1 by 2 tau radians per second. So here 1 by 2 tau omega n, here both make it equal. That means 1 by 2 tau equal to what? Root of k by tau. Square it. If you square it, what I will get? 1 by 4 tau square equal to what? K by tau. So now 1 tau is cancelled. That means k equal to what? Tell. 1 by 4 tau. K equal to 1 by 4 tau. This is equation number 1 you take. The second data what is given? So steady state error is 0.5 given. Steady state error given 0.5. ESS equal to 0.5. Given for what? Unit ramp input. Unit ramp input. Unit ramp input. So first find kV. You find first what? kV you find. First find kV. kV equal to what? Limit s tends to 0, s into g of s. That means limit s tends to 0, s into what is g of s? K by s into s tau plus 1. So ss cancel, s tends to 0. That means kV equal to k. Then steady state error equal to what? A by k. Unit ramp input mentioned. That means ESS equal to what? 1 by k. Equal to what? 0.5 given. That means k equal to what? 2. The answer is k equal to 2. The answer is k equal to 2. And now find tau value. So 2 equal to what? 1 by 4 tau. So tau equal to what? 1 by 8 means 0.125. Tau equal to 0.125. So 2 comma 0.125. Answer C. Next question. The open loop transfer function of a feedback control system given. With respect to root locus diagram, which of the following is correct? They are asking. So here find centroid, angle of dip, asymptotes, and then breakpoint. All this we have to check it. So if you draw the root locus diagram here, so pole locations if you take it, so g of s, h of s given as what? Tell. K by s into s square plus 6s plus 12 is given. Represent the poles and zeros in the s plane. So one pole at what? Origin. Another pole at where? -3. -3 plus j root 3 and minus j root 3. K0. 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 So first you check it what? Centroid. Centroid equal to sum of real part of the poles minus real part of the zeros divided by P minus Z. What is the real part of pole? -3 minus 3. No zeros divided by P minus Z is 3. So that means centroid is -2. Centroid -2. Next what you have to check? First one centroid. Angle of asymptotes. Here number of asymptotes 3. N equal to P minus Z. So P minus Z. 3 minus 0 equal to 3. So angle is what? When Q equal to 0, you will get 180 by P minus Z means 3. Means 60. So next angle 180. 3 asymptotes now 180, 300. That means angle of asymptote 60, 180, 300. Next, what you have to check? Based on the options, you should check it. Next, break point. Find the break point. Break point means simply differentiate dk by ds equal to 0. So differentiate it d by ds of given function. If you take 1 by s cube plus 6s square plus 12s equal to 0. Differentiate it u dash 0 minus u into. So if you solve this, 3s square plus 12s plus 12 equal to 0. Then s square plus 4s plus 4 equal to 0. That means what? S plus 2 whole square equal to 0. Break point is what? S equal to minus 2. Break point is minus 2. So it lies on the what? Root locus branch. Minus 2 is lies on the what? Root locus. This is here root locus branch exists. So here break point. This minus 2 is a valid break point. That means what are the options correct here? Centroid minus 2 correct. The second one wrong. Third one C is correct. D is wrong. So that's all. Thank you. Here the closed loop transfer function of the system given. Number of poles on j omega axis are they asked. So directly given closed loop transfer function. Then we can write the directly characteristic equation. So denominator is a characteristic equation. That is s power 5 plus 7 s power 4 plus 6 s cube plus 42 s square plus 8 s plus 56 equal to 0 is the what? Characteristic equation. So now you write the Routh array. This is s power 5, s power 4, s cube, s square, s power 1, s power 0. So first coefficient 1, alternate is 6, alternate is 8, next 7, alternate is what? 42, next alternate is what? 56, alternate 56. Here we can divide with what? 7. So 7 1 ja, 7 6 ja, 7 8. So then again do the s cube coefficient, you write 1 into 6 minus 1 into 6 means 0. Again 8 minus 8 0. So here 0. We are getting what? 1 time row of 0. 1 time row of 0. Then we need to form the what? Auxiliary equation. Form the auxiliary equation. What is auxiliary equation? Tell. Auxiliary equation is, so 1 into s power 4 plus 6 s square plus 8 equal to 0. So differentiate it. Differentiate auxiliary equation with s, then 4 s cube plus 12 s. That means s cube coefficient replaced by 4, then s square coefficient replaced by 12. Again I can divide this with 4. If you divide with 4, 4 1 ja, again 4 3 ja. Then again what we are getting? 1 into 6 6. 6 minus 3 become 3. 3 by 1 means 3 only. This 8 we can bring into diagonally. So here also 8. Then again what we are getting here? 9 minus 8 become what? 1. So 1 divided by 3. So now you observed it. So below auxiliary, above auxiliary. You divide the Routh tabular form into below auxiliary and above auxiliary. So if you take below auxiliary equation, there is no sign change. No sign change means what? All the poles must lies on the what? Imaginary axis. How many poles? Order of auxiliary equation, fourth order. That means 4 poles compulsory lies on the what? Imaginary axis, because no sign change below auxiliary equation. That means the number of poles on j omega axis equal to 4.
We'll see the question which were asked in pre-gate examinations from the subject networks. I have a question like this. The Thevenin's voltage and Thevenin's resistance across A, B terminals of the circuit shown in the figure. So there is a circuit he has given. The circuit consists of dependent source, of course current controlled voltage source, and other resistors connected in series and parallel combination, and is asking the resistance across this A and B terminals. You know, as a network consists of only dependent source and resistors, there is no independent source. As there is no independent source, you don't get, you know, the Norton's current or otherwise the Thevenin's voltage. They are absolutely going to be zero, because it is not an energized network. It is unenergized network. It is a dead network. Even you touch these terminals also, you will not get any shock, because internally this network doesn't consist any active element. As there is no active element, you don't get any shock. So I can say that the Thevenin's voltage is absolutely going to be 0. So 2 cannot be the answer. 0 could be the probable answer. 0 could be the probable answer. Okay, 0 could be the probable answer. So either B or D could be the correct answer. Now let us check for Thevenin's resistance. How do you calculate Thevenin's resistance? No active elements, so no need to short circuit or open circuit some sources. You just connect a known voltage across this AB terminals. It's your wish. You want to connect a voltage source or current source, it's your wish. Okay. So the known voltage may be V. Some people assume V. They'll go ahead with the V and I equation. They'll end up with a V by I and they'll solve RTH. So if this voltage source is going to drive a current, some current I. Okay, already capital I is there, so that's why I'm writing it as I. So let me assume this voltage source value, some value, because it makes very easy. Because if you know this current value, you can find out this voltage source value, dependent source value, and that will make the calculations very easy. Okay, right. So how do you want to make this voltage? How much you want to make this voltage source value? Let us make it as 12. No, if it is make it as 12, 12 divided by 12, you will get the current as 1 ampere. Gone, finished. Now if I is 1 ampere, 8 into 1, it will be 8. It will be 8. Okay, dependent voltage source, so I am just writing it as 8. Okay. Now the voltage across till this parameter, till this nodes, it will be 12 volts only. Now you can apply nodal analysis and you can find out the currents value. At the end, you should get the resistance. The resistance must be written in terms of V by I. What is V? 12. 12 by I. So either you do this way or you do source transformation also. People can also go for source transformation. I have 8I and I have 4 ohms. It is looking like a practical voltage source, dependent source. So 8I divided by 4, you will get 2I. 2I in parallel with 4 ohms. The network looks like this. The network look like this. Okay, 2I in parallel with 4 ohms. We know you can, it's your wish, you can connect to 12 volts non-voltage source and it is going to drive a current I. Now 12 by 12, so you will get it as 1 ampere. 12 by 6, you will get it as 2 amperes. 12 by 4, you will get it as 3 amperes. What about this value? 2 into 1, you will get it as 2 amperes. So 2 ampere is entering, I is entering. How much current is leaving? 3, 2, 5. So 2 plus I is equals to 3 plus 2 plus 1. It will be 6. 2 plus I is equal to 6, I is equals to 4 amperes. So I have got I value as 4 amperes. What does it mean? This entire network is drawing 4 amperes current when you connect a voltage source of 12 volts. So which means the resistance offered by this network across AB terminals, RAB or otherwise RTH, you can call it as 12 by 4, you will get it as 3 ohms. So the Thevenin's resistance is going to be 3 ohms. So obviously I can say option D is going to be the correct answer. You can eliminate 2 options out of 4 options if you know the concept of only the network has only dependent sources along with the resistance, then it doesn't consist any Thevenin's voltage and Norton's current or short circuit current. Okay, be careful. It is equivalent to a dead resistor, unenergized network. Okay, I hope it is clear. Either you go ahead with the nodal analysis or you can go ahead with the basic source transformation and you do that, you will get it. KCL, you will get it. Let us see one more question. For the network shown in the figure, what is the expression for I of t? Assume that initial current in the inductor is 0. There is no initial energy in the inductor. I have a impulse signal, of course delayed by some 3 seconds, 2 del of t minus 3, and I have a RL series network and is asking a current. As it is definitely a RL series circuit. Whenever you give a supply, definitely it looks like the inductor will not allow the current immediately, right? The inductor will not allow the current immediately. Okay, so definitely it looks like this. So what you need to do, you need to convert this network into S domain or frequency domain. R will be R only, the inductor will be like SL ohms, and this will be how much it will be? 2 into e power minus 3s, and this will be I of s. So your I of s will be how much now? I of s is equals to V of s divided by Z of s. So you substitute those values, you will get it, and after that you will get the apply inverse Laplace transform, you will get it. So how much it will be? 2 into e power minus 3s divided by Z of s, how much? R plus SL, that will be 2 plus s into 1. L is 1 Henry na? Okay. So this is my I of s. You apply inverse Laplace transform. If you apply inverse Laplace transform, it will be s plus 2 na? So numerator it is 2. 2 into e power minus 2t. S plus 2 na? So exponential alpha will be minus 2. T. What is t? The t is not started at 0 point, it is delayed by 3 seconds. So t minus 3, because the excitation is not starting from 0. You can take up like if it is del of t, you would have write it as 2. Okay. So it is t minus 3. So be careful. E power minus 2 into t minus 3. So this is how actually you have to get it, and this u of t minus 3. Be careful. Delay, the response is delayed by 3 seconds. So I of t is equals to 2 into e power minus 2 times t minus 3. Yeah, this is matching. Option B is matching. Option B is matching. Most of the people will go ahead with this one. Be careful. Be careful. Okay. So be careful. Okay. Right. We'll have a look at this question. What values of RL and RC will cause the circuit shown in the figure below to be resonant at all frequencies? I have a practical inductor and a practical capacitor connected in parallel. Now for what values of resistance RL and RC, these L and C circuits comes under resonance? I think for parallel this kind of network, the resonant frequency value is taken as 1 by root LC into root of RL square minus 1 minus L by C divided by RC square minus L by C. Okay. So when the resistors RL and RC values are going to be 0, simply omega naught is equal to 1 by root LC. But he is asking for what values the circuit comes under resonance. There is a direct case. RL value, RC value must be equal, and they must be equals to root of L by C. If it is so, the imaginary term will become 0. The imaginary term will become 0 and the circuit comes under resonance. Resonance is nothing but imaginary term, the omega term should be, j omega term should be 0. Okay. I have a L value, how much? 2 milli. I have a C value, how much? 80 micro. Okay. So let me solve this one. 2, you will get it as 1 by 40. 10 to the power of minus 3, if it 10 to the power of minus 6, if it goes up 10 to the power of 6. So you'll remain with 10 to the power of 3. So 10 to the power of 3 is 1000. So root of 1000 divided by 40, it comes out as 25. Root of 25 will be 5. So RL value, RC value must be equals to 5 ohms. Okay. So if RL value and RC value is equals to 5, then I can say that this circuit resonate at all frequencies. The circuit will resonate at all frequencies. Okay. I have a question like this. The network of figure attains steady state with the switch closed. With the switch closed. If the switch is closed, the network attains a steady state. And is asking that, he's telling that at t equals to 0, when the switch is opened, at t equals to 0, the switch is opened. Which of the following statements are correct? He has given some statements. The voltage across the capacitor Vc at t equal to 0 minus is 2 volts. The inductor current is 1 ampere at t equal to 0 plus. The voltage across the switch Vk at t equal to 0 plus is 0 volts. And dVk by dt at t equal to 0 plus is 4 volts per second. The rate of change of voltage across the switch he has mentioned. Okay. So if you want to observe those values, let us take up the initial situation and then next after switching action. Okay. He initially is saying that the network attains a steady state with the switch closed position. So switch is opening at what position? At t equal to 0. That means what? From t equals to minus infinity to 0 minus, the switch is in closed position. From minus infinity to 0 minus, the switch is in closed position. Okay. If the switch is in closed position for a long time, is that source is connected? Yes, the source is connected. This 2 volt source is going to drive the current through inductor, and of course it is also going to drive the current through capacitor. Inductor and capacitor are going to charge and they will attain the steady state. If they attain the steady state, by the time you are going to open the switch at t equal to 0, just before the opening the switch, that is t equal to 0 minus, this situation is called as, or this instant is called as steady state instant. Because a long time the source is connected. If the source is connected for a long time, the inductor and capacitors will charge and it will store the energies. Definitely they will reach the steady state. In the steady state, inductor behaves like a short circuit and capacitor behaves like a open circuit. You replace the inductor and capacitors with short circuit and open circuit. Inductor with short circuit, capacitor with open circuit, and find out the currents and voltages across them. Okay. So at t equals to 0 minus, this is the network. Switch is closed, capacitor is open circuited, inductor is short circuited. Now you see, this 2 volt source is going to drive the current through the switch and also through the inductor through the 1 ohm resistor. Okay. Is there any current through the capacitor? No, because capacitor is open circuited. Right, in the steady state capacitor is open circuited. Now IL of 0 minus is equals to voltage divided by resistance, you will get it as 2 amperes. So IL of 0 minus is equals to IL of 0 plus. Inductor will not allow the current suddenly. Inductor will not allow the current immediately. Right, inductor will not allow the sudden changes in current. So IL of 0 minus, IL of 0 plus is 2 amperes. What he has mentioned, the inductor current is 1 ampere at t equal to 0 plus. Is it true? No, no. This is absolutely false. Any other voltage across the capacitor? Voltage across the capacitor, Vc of 0 minus is 2 volts, he is saying. Let us see. You see here, the switch is closed, which means what? Short circuit or not? Switch is closed. What is the value of resistance of that switch? The resistance of the switch is going to be 0, no? Even though the current is 2 amperes into 0 ohms resistance, it will be 0 volts only. So Vc of 0 minus is going to be how much you are going to get? It's going to be how much? 0. So Vc of 0 minus is 0. Vc of 0 plus is also going to be 0 or not? Why? Because capacitor will not allow the sudden changes in voltages. So Vc of 0 minus is 0, but he has mentioned that 2 volts. No, absolutely wrong. Option A and option B are absolutely wrong. Now let us have a look at C and D. The voltage across the switch Vk at t equal to 0 plus is 0 volts. At t equal to 0 plus is asking. That means what? Just after opening the switch. So from 0 minus to 0 plus, what is the time? It is 0 only. So we call this state as transient state. Immediately after the switching action, na? Immediately after the switching action is nothing but transient state. In the transient state, inductor behaves like a open circuit, capacitor behaves like a short circuit, because it doesn't want to allow the sudden changes in currents and voltages. Inductor wants to allow the previous value of current only. Capacitor wants to maintain the previous value of voltage only. That is the reason why it wants to it will become open circuit and capacitor will become short circuit. So at t equal to 0 plus instant, the network look like this. The network is in transient state. Here the network is in steady state. Whether the network is in steady state or transient state, the network is of resistive nature. Remember that point. You see. Now here switch is opened at t equal to 0 plus. What is the behavior of capacitor? Short circuit. What is the behavior of inductor? Open circuit. But replace their initial values, previous values. So the capacitor Vc of 0 minus and Vc of 0 plus, how much? 0 volts, previous value. IL of 0 minus and IL of 0 minus. IL of 0 minus, previous value. How much? How much? 2 amperes. Okay, right. What is asking? The C option, the voltage across the switch Vk at t equal to 0 plus is 0 volts. Is it so? Yes, it's a short circuit. Vc of 0 plus is how much? That is equals to Vc of 0 minus. You will get it as 0 volts. Yes or no? So voltage across the switch at 0 plus instant is going to be 0 volts. So do you have any voltage across a capacitor? No. So I can say that option C is a correct statement. True. Option D, dVk by dt at t equal to 0 plus instant is 4 volts per second. How do you calculate the change in voltage across the switch? If you want to calculate the change in voltage across the switch, you need to calculate the change in current through the capacitor. The current through the capacitor IC can be taken as C into dVc by dt. I want a t equal to 0 plus instant. So IC of 0 plus divided by C is equals to dVk by dt or dV of 0 plus by dt. Is there any current which is flowing through the capacitor at t equal to 0 plus? Yes. How much? Inductor previous current. How much? 2 amperes. It is flowing through 1 ohm resistor, 2 volts voltage source and the diversion. It will divert like this. So the current flowing through the capacitor at t equal to 0 plus instant is how much? 2 amperes. And what is the capacitor value? I think 0.5 farads, 0.5 farads. Now this is my voltage across the switch just after opening it. The change in voltage across the switch just after opening it. 2 by 0.5, you will get it as 2 into 2, probably 4. So 4 volts per second. So voltage across the switch is changing as 4 volts in a second. Okay. So I can say that option D is also correct statement. Option D is also correct statement. Okay. So on the whole, option C and option D are correct statements. This is an MSQ. Look at this question. For the circuit shown in figure, the value of quality factor Q is. The circuit is given with some resistor, inductor, capacitor and with a dependent source, voltage controlled current source. He is asking quality factor. So let us, if you want to find out the quality factor, you should operate the network under resonance condition. Because quality factor omega L by the formulas are there, but anyhow, if you operate the network under resonance condition, okay, the energy in the inductor will be half Li square, na? The energy in the capacitor will be half CV square, na? Okay. Quality factor is nothing but what? Quality factor of the inductor generally. Dissipation factor of the capacitor we will take up, reciprocal. If you want to test the quality factor of the inductor, you should allow maximum current through the inductor. When will you get maximum current? If the circuit under resonance, series resonance condition, the current will be maximum. Under parallel resonance condition, voltage will be maximum. So if you want to test the capacitor, parallel resonance is preferred. If you want to test the inductor, series resonance is preferred. So anyhow, he has given RLC. So you take up this dependent source network and convert into voltage source manner. Okay, voltage source manner. Okay, so how do you convert 0.3 VR current into ohmic value? Ohmic value is what? 1 by j omega c. 1 by j omega into 30 into nanofarad, na? So 10 to the power of 9. So 0.3 VR into j omega 1 by j omega 30 into 10 to the power of 9. So this is my voltage source magnitude. Be careful, the current source direction is downward, so plus minus like this you will get. And anyhow, the capacitive reactance value will be in series with the existing other two parameters. Now here also you can write j omega L. So j omega L value is 1 millihenry. Okay. So these are my ohmic values. Okay. So if you convert like this, it looks like a series RLC circuit. It looks like a series RLC circuit. So if it looks like a series RLC circuit, you should allow the network, you should bring the network into resonance mode, allow a large value of current so that you can store maximum value of energy in the inductor. That is where you'll get to know how much energy can be stored in the inductor, and based on that you can decide the quality factor. If the inductor stores less amount of energy, I can say that that is not a quality inductor. Yes or no? If it is dissipating more and more heat, if it is storing less amount of energy in the magnetic field, that's a worst inductor, no? So allow maximum value of current so that you will come to know how much energy it is storing. If it is storing maximum energy, it's a good inductor. If it is storing less energy, it's a worst inductor. So let us convert this network into, see just in a single loop manner and solve it. So this is how the network looks like. So we are current into the reactance. I have written all these values. Now after getting this one, you see the network has dependent source and the rest, ohmic values. So anyhow, you should connect a voltage source, and this voltage source divided by current, you will get the impedance. Because he is asking what? He is asking quality factor. So as it is series network, I am going with the series RLC network, the quality factor will be omega naught L by R. Omega naught L by R. So if you can calculate the resonant frequency, you can calculate the quality factor now. Okay. So to calculate the resonant frequency, under resonance condition, what will happen? The ZTH real term plus imaginary term. This imaginary term will be 0. So take up that imaginary term and make equal to 0, you will get the omega value. Once you get the omega value, substitute here, you will get the quality factor. Okay. So let us do that one. So I have a known voltage source which is driving a current I, and that current I is flowing through this network. So if I flows here, what is VR here? So VR voltage drop across the 10 ohms will be 10 into I. According to the current direction, the polarities are given. In the network itself, the polarities are given. So I assume the current direction to match that polarities. Okay. So wherever VR is there, I can replace with 10I. So here also I have VR. Now simply you can write a KVL and write in terms of KVL. So you will get it now. So let me go ahead with this. Okay. Let me go ahead with this one. So if I solve this one, plus V minus I into j omega into 10 to the power of minus 3 minus VR is going to be, VR is how much? VR is how much? 10I. So minus 10I into 10, it will be 100I minus 10 to the power of 9 divided by j omega into 30. And what I left with this one. Be careful, don't change the polarities of this voltage source. Okay, don't change the polarities of this voltage source, already polarities are there. So leaving polarities plus, so plus 0.3 VR plus 0.3 VR plus 0.3 VR into 10 to the power of 9, yeah, into 10 to the power of 9 divided by j omega 30. Okay, so this is the voltage KVL equation I am going to get. So you can take up I terms separately, So if you take up I terms, anyhow, and this VR also has, moreover, this VR also has what? 10i, na? So you can replace 10i. So all these terms has I terms. So you can take up common now. I, if you take up common, then it comes out as j omega into 10 to the power of minus 3 plus 100i, or plus simply 100, and this plus 10 to the power of 9. If this j omega, if this j goes up, it will be minus j, or let me write this as j omega 30 plus 0.3 into 10, it will be 3i. So I have taken common, so 3 into 10 to the power of 9 divided by j omega 30. So this is how it is looking like. Let me even write much more clear. All I terms I have taken common. So let us take up the real terms and imaginary terms separately. So V by I is equals to, real term I have only 100, and let me make out imaginary terms as like this. So j omega into 10 to the power of minus 3. If this j omega, if this j goes up, it will be minus j. So minus j into 10 to the power of 9 divided by omega 30 minus j into 10 to the power of 9 divided by 3/10. So I get this as omega into 10. So this V by I looks like this. This V by I is nothing but ZTH, na? So I have a real term and I have an imaginary term. So make the imaginary term equal to 0. So let me make the imaginary term equals to 0. So if I make imaginary term equals to 0, I'll get like this. So j into 10 to the power of 9 divided by omega into 30 plus j into 10 to the power of 9 divided by omega into 10. Okay. Yeah. So if you try to solve this one, 10 to the power of 9 j, you can take up common 2 divided by omega, like that. Okay. Anyhow, so let me end up this. Let us not get into the entire calculations. You can solve them. I'll get some omega naught. You cross multiply, you'll get some omega naught radians per second. Okay, you'll get some omega naught radians per second. So after getting that omega naught, you substitute here omega naught into the inductive reactance. How much it is? 1 milli. Sorry, inductance. What is the resistance value? The resistance value 100. Is there any change in resistance? Oh, probably I have got it as 110 into, I think I made a, I changed this one, be careful. Actually, I should take up only the voltage drop across this one. So voltage drop can be taken as simply 10 into I only. It should be 10 into I, not 100I, it should be 10 into I. Okay, it should be 10 into I. So be careful, any calculation mistakes are there, be careful. So it should be 10 into I only. So the real term you will get this as 10 only. Okay. So omega naught, you solve it, probably you'll get that one, and you'll get it around some kiloradians, 365 some kiloradians you'll get anyhow. Okay. Remember, I wanted to tell you one point here. A capacitive reactance in parallel with the dependent source. So there is a change in capacitive reactance value. Generally, when a resistance is connected in parallel, or when the resistance is placed in accordance or in conjunction with the dependent source, that element nature is going to be changes, that element value is going to be changes. So as a capacitor is connected in parallel with the dependent source, the capacitive reactance will change. If a resistor is placed, resistor value will change. If inductor is placed, inductive reactance value will be changed. That's the reason why you see here, the real term, the resistance value is not changed. The resistance value is not changed. So be careful. Okay. So resistance value still is going to be 10 only. Okay. So you end up this, try to solve this omega naught and substitute here directly, you will get the answer Q. Okay. We will see one more question here. The question is like this: for the network shown in the figure, the value of RL for maximum power transfer. What is the value of load resistance for maximum power transfer? And the maximum power transferred are respectively. What is the value of maximum power transfer to the load resistance? Is asking RL value, is asking PL max value also. Both. Is asking maximum power also. Okay. So how do you get this RL value? Generally we do, what we do, you just disconnect this secondary port so that you can calculate VTH and RTH, and that RL must be equals to RTH. Yes or no? Disconnect this, make I2 equal to 0, disconnect this means what? Make I2 equal to 0, calculate VTH, calculate RTH. Now your RL must be equals to RTH for maximum power transfer. Whenever you disconnect the second port, I2 equal to 0, you substitute I2 equal to 0 in the two-port network equation. I have got ABCD parameters. ABCD parameter equations, you see, be careful about the current directions. Current is into the network. So I can take up sending end voltage is equals to receiving end voltage plus the drop. So A V2 plus B I2. V1 is equals to A V2 plus B I2. I1 is equals to sending end current is equals to C V2 plus D I2. Anyhow, I am making I2 equal to 0. So left out terms you can substitute and write down. And while writing V1, be careful, V1 is not directly, don't substitute 100. V1 is the voltage across this input port after some drop in the 20 ohms resistance. How much drop it is? 20 times I1. 100 minus 20 times I1. So V1 is what now? V1 is 100 minus 20 times I1. Okay. So replace that and solve for VTH. So I am replacing V1, 100 minus 20 times I1 is equals to 4 V2. I2 I am substituting 0. Okay. So the second equation, how it looks like? I1 is equal to 0.4 times V2. I1 is equals to 0.4 times V2. Now you substitute this I1 here. So 100 minus 20 times 0.4 times V2 is equals to 4 times V2. What is V2? Secondary side port voltage, na? VTH, na? Directly. So 20 into 0.4, it will be 8. 8 V2, send on to the right side, it will be 8 plus 4, 12. So V2 is equals to 100 by 12, which is nothing but VTH. 100 by 12, it will come out as even 12 5s are 60, yeah? So 12 8s, maybe 12 7s like that. Okay, not even 12. Okay, let us check that one also. 100 by 12. I am getting it as around 8.33. He is not asking Thevenin's voltage, he is asking what? Thevenin's resistance. So if you want to calculate Thevenin's resistance, you need to replace the independent voltage sources by their internal resistances and independent current sources by their internal resistances. Okay. So I have an independent voltage source replaced with internal resistance, that is 20 ohms. So you can replace it with short circuit. Short circuit means what? How do you get? If you short this one, what is V1 now? V1 is going to be just minus 20 times I1 only. Okay. Now when you solve for RTH, what is this V1? Minus 20 times I1 is equals to, this is AV2. This V2 is nothing but what? Open circuit voltage on the side. So here, to calculate the Thevenin's resistance, we connect a known voltage source. You connect a known voltage source and drive some current I. Okay. So this is V2 and I2 you can take up. Whatever the current which is driven by the voltage source. You connect a voltage source that is going to drive some current. I am assuming that as I am assuming this voltage as V. So that's the reason why I am replacing V2 as V. I2 as I. So minus 20 times I1 is equals to 4V plus 20 times I. Okay. Now what about this? What about this equation? What about this equation? I1 is a I1 you can substitute here now. Minus 20 times 0.4 times V plus 3 times I is equals to 4V plus 20 times I. 20 into 0.4, 8V minus 8V, 60 minus 60I is equals to 4V plus 20I. Voltage will be around minus 12 volts, minus 12V, and this will be around 80I. So V by I will be 80 by 12. So 12 5 is 60, no? So more than 5. So 80 by 12 coming out as around 6.67. So this is my RTH. This is my RTH 6.67. So there are two options which are matching. Option B and option C are matching. So we have solved only RTH. Now you need to solve with the PL max also. So what is PL max? What is PL max? How do you solve PL max? You replace the network with Thevenin's voltage, Thevenin's resistance, and connect the load resistance and vary till RTH. So for PL max, what is the formula? Simply IL square into RTH. You can write IL square into RTH. Otherwise, formula is there, right? VTH square divided by 4 times RTH. How much we have got VTH? VTH we have got it as 8.33. Whole square divided by 4 times RTH, 6.67. So 6.67 into 4, 8.33 square divided by answer. If I do it, I am getting it as around 2.6 watts. 2.602 watts. So 2.6 watts. So this is matching. So option C is matching. Okay. Right.
Hello GATE aspirants. Here in this session, I am going to solve the pre-GATE questions from digital electronics, and exam was conducted by ACE Engineering Academy. And see, let us solve the questions from ECE paper. The Boolean function obtained from the output of the given circuit if C is a node, is stuck at logic 1. So, some initial data is provided that this node is initially locked to the logic 1. So, whatever may be the reason, just you assume C is fixed at logic 1 and you just proceed. It is just basic logic gates related question. See, if one input of exclusive NOR gate, this is exclusive NOR gate, you know. If one input of exclusive NOR gate is logic 1, then this exclusive NOR gate can act as a buffer. Example, X NOR 1 is equals to X. Like that, output of this exclusive NOR gate is automatically the second input. What is the second input? B. So, B will reflect at the output of X NOR gate. As usual, XOR gate will do the operation between A and B and it will produce A XOR B. Right? A XOR B. Then what is the output? Let us assume the output is Z0. Z0 is equals to, anyways this is 1 dot B and operation with A XOR B. So that A XOR B dot 1 dot B. So Z0 is equals to A bar B plus A B bar dot B. B dot B bar 0, Z0 is equals to A bar B. in the circuit shown, the clock frequency, that is the frequency of the clock here, it is a synchronous circuit, okay, is given as 10 kilohertz. If the initial value of the counter is at 0, 0, then find the frequency at output Q naught. Here we are going to find the Q naught, I mean frequency at Q naught. Actually, if you see the circuit like this, immediately you should understand the basic rule of any counter. So, output frequency of any counter is equals to input frequency or clock frequency divided by its modulus number. So, you suppose to find the modulus number of this counter. What do you mean by modulus number? Number of states producing by the counter before get restart. And it has given initial state as 0, 0. And my dear friends, what are the expressions for D0 and D1 here? If you observe it, T1 is equals to end operation of Q1 bar and Q0 bar. So, Q0 bar dot Q1 bar. What is the T0? This is a direct output from the first flip-flop, which is Q1, right? Now, these are the expressions for T1 and T0. So, we have to take the initial data, accordingly you should identify T1, T2, T0 values, and then you should guess the step or you should guess the state producing by the flip-flops. Both are T flip-flops, you know well. In a T flip-flop, if T0 after clock excitation, output will maintain its previous state. It is not going to change. When T value is at 1, if you apply the clock, output will be toggle. Toggle means complement of its previous value. So, this is actually the thing we are going to execute on the given circuit. Initial value 0, 0. So, that I am writing initial values Q1, Q0, and I did not apply any clock pulse here. No clock is applied and initial value 0, 0. So, if this is 0 and 0, I am going to overwrite the data. So, please try to follow it. 0 bar 1 and 0 bar 1. 1.1, 1. What is the T1 value now? 1. If I apply the clock simultaneously, okay, simultaneously we are going to apply the clock. Then what will happen? No propagation delay provided, no need to worry about it, right? So, first flip-flop is going to toggle because T value is 1. Second flip-flop is going to preserve the same data. Why? T0 is 0. After first clock pulse, if I apply the first clock pulse, what is going to happen? First flip-flop will toggles, 0 change to 1. Second flip-flop will maintain the same state. This is the sequence after 1 clock. So, don't forget to update the data, right? So, what is the next sequence here? 1. And next sequence here, same data 0, 1, 0. Before applying the clock, identify T1 and T0. You can substitute the values here, otherwise directly you just work out the circuit, like by observing the T1, T0 values, we can take a guess, right? Now, as one of the terminal is 0, look at this. One of the terminal is 0 means Q1 is 1, 1 bar 0, right? One of the terminal of AND gate is 0. So, T1 value will be 0 now. What is the T0? Already it is 1. It is going to toggle after clock pulse, right? So that if you apply one more clock pulse, first flip-flop will maintain the same state. First flip-flop will maintain the same state. Second flip-flop is going to toggle. But remember guys, these things will happen simultaneously because we are providing simultaneous clock excitation for both the flip-flops. Okay. So, what is the updated data? 1, 1. Let me update the data. Q1 value is 1. Even Q0 value is also 1. 1 bar 0. If any one of the input is 0 for the AND gate, output will be 0. So, still this is 0, right? Still T1 is 0. And what is the T0 value? What is the T0 already available? Look at this. 1. 1 means it is going to clock, means it is going to toggle again. If I apply the third clock pulse, right? Third clock pulse. Q1 is maintaining at the same state, that is 1. But Q0 is going to toggle. Sir, 1, 0. Sir, we have obtained again 1, 0, which is repeated state. Of course, yes. Now, you don't need to apply the next clock pulse. You know the rule, right? Because if this is 1 and this is 0, look at this. Q1 value is 1, Q0 value is 0. if this is 1 and if this is 0, right? You know what is going to happen. 0 complement 1, but Q1 value 1, 1 complement 0. Still T1 will be locked at 0. It is not going to change. And again T0 value is 1. T0 value is 1, so that it is going to complement the output of Q0. 0 will change into 1, 1 remains 1, so that 1 1 will get. So what is the 1 1 after the state of 1 0? So 1 0 1 1, 1 0 1 1, 1 0 1 1. Only these states are going to repeat. 0 0 is initial state, right? Once if the counter is started sequence, you cannot see that 0 0 again. That's why you should call it as lockout state. What are the states which we can see repeatedly? 1 0 and 1 1. How many states? Only 2 states. Number of states 2. So that modulus number is 2. Given is mod 2 counter. Given is mod 2 counter, right? Then automatically, what is the output frequency? This is one way. We don't need to discuss multiple ways of the solution. This is one way you can solve like this. Output frequency is equals to clock frequency divided by 2. So clock frequency is given as 10 kilohertz. So 10 by 2, 5 kilohertz. 5 kilohertz is the output, right? Answer for the question is 5 kilohertz. Now we'll go for the next question. The module 4 up counter. So given is a up counter. This is a clock and a synchronous counter. Okay, right? Shown in the figure, the output of 2 input logic gate. This is the output of 2 input logic gate is used to clear the flip-flops. Assume that counter is started from all clear states. I mean clear states means all zeros, okay? Then 2 input gate is, what is a gate inside this block? This is a question. Of course, this is a previous gate model, important model, right? So very simple, given is a mod 2 counter, sorry, mod 4 counter. Given is a mod 4 counter. So mod 4 counter is going to produce 4 possible states. So actually an asynchronous counter, an asynchronous modulus counter is having a modulus number, assume m. Then automatically at the value of m, the counter should restart. So 0, 1, 2, 3 are the values must be produced by this counter. Exactly at 4, whenever the 4, 0, 1, 0, 0 is arrived, immediately the counter has to be clear. Then only it can act as a mod 4 counter. And it is up counter. It's a basic standard counter, right? So that Q3, Q2, Q1 and Q0 are the binary outputs of the counter. Initial states all zeros. As it is up counter, for every clock, the count sequence will increases like this. For the second clock pulse, value is 1, 0. For the third clock pulse, value is 1, 1. And for the fourth clock pulse, the counter has to be clear, 0, 1, 0, 0. Of course, the counter is actually doing its work. That's why this counter is actually called as mod 4 counter. He said that given is mod 4 counter. So this counter automatically will clear, automatically will restart. Clear in the sense what? Restart from initial states after the fourth clock pulse. So these two, Q3 and Q2 are directly connected to the input of 2 input logic gate. So that whenever you see, whenever the Q2 and Q3 values are 0, 0, this is not going to take any action, that you have to understand, because this is only the different thing. Combination is different for Q2, Q3, Q2. These are the inputs of logic gates. Exactly when 0, 1 arrived for the inputs of logic gates, generating a clear signal. What is a clear signal? Active low type. All flip-flops are active low clear type. So that 0 is a clear signal. Okay, right. 0 is a clear signal. So that whenever the inputs of this logic gate are 0 and 1, then outputs are 0. Output is going to be logic 0. So which logic gate can give output 1 for input values are 0, 0 and output is 0 if inputs are opposite to each other, either 0, 1 or 1, 0 of course. according to the given data. Exclusive NOR gate. What is the truth table of exclusive NOR gate? For example, if you take A, B as inputs, output lines are A, X NOR B. 0, 0, 0, 1, 1, 0, 1, 1. If inputs are 0, 0, output is logic 1. If inputs are either 0, 1 or 1, 0, output can be 0. Even inputs are 1, 1 also output is 1, but we need only this portion because here the possibility is only either 0, 0 or 0, 1, that's all. Once 0, 1 is arrived, automatically counter will go back to clear state. That means initially it will start from 0, 0 state. So that only chances to get at the input like 0, 0 and 0, 1. So which one is a suitable gate for this? Exclusive NOR gate. B is a correct option, right? You can check the remaining gates, but X NOR only will satisfy this condition. Okay guys, now determine y1, y2, y3, y4 in the following multiplexer. Actually this multiplexer is implemented for this function sigma m of 0 to 5, 7. It is a SOP function. SOP function. If you observe carefully, this is actually a 4 to 1 multiplexer, 4:1, implemented by 3 different 2:1 multiplexers. What is the general formula? General procedure to identify the missing variable? See, A and B are connected as select lines. We are going to program the C. How? Y1, Y2, Y3 and Y4. A bar, B bar, A bar, B, A, B bar and A, B. Is C bar, C. 0, 1, 2, 3, 4, 5, 6, 7. Right? These are the minterms of a 3 variable function. So this is a system designed for what? 0 to 5, 7. So 0, 2, 5 and 7. What should be the pin values of y1, y2, y3, y4? y1, y2, y3, y4. Pin values should be C bar, C bar. We need 5 and 7, so C and C. So y1, y2, C bar, y3, y4, C. A can be the correct option for this. Okay. So these are the questions found from EC paper.
Hello everyone. Let us see 1 mark questions related to signals and system subject. What is the given question? Find the value of the given integral. This is linked to the standard property of impulse. So try to use the shifting property of impulse. What is that property? Integral t1 to t2 x of t into del of t minus t naught dt equals to x of t naught. Shift should lie within the limits. Shift should lie within the limits. That is a standard property. So t square e power minus t is looking like x of t into del of t minus t naught. What is the shift value? T naught value equals to 2. So first we have to check whether the shift is within the limits or not. Of course, the range is minus infinity to infinity. So directly in the signal, t place t naught value, that is 2 square e power minus 2. Substitute that shift, 2 square e power. So this is indirectly 4 e power minus 2, 4 into 0.135. E power minus 2 is 0.135. So the answer becomes 0.54. Very simple question based on the shifting property of impulse. So let us observe the next model. Observe the data. It is known that the Laplace transform x of s has 2 distinct poles. There are 2 poles. One pole is located at s equals to 0, other at s equals to minus 1. It also has a single 0 at s equals to 1. Poles and zeros are given. Final value of xt is 10. It is stated that
x of t as t tends to infinity equals to 10, then find the signal for the given data. So, how we are in a position to write the Laplace domain expression for this? We have single 0 at 1, so k into s minus 1, but 2 poles, that is s into s plus 1. How to obtain that k? From the given condition, So, let us apply final value theorem of Laplace. What is final value theorem? Limit s tends to 0, s into x of s. What is that number given? N equals to limit s tends to 0, s into, what is x of s we considered? K into s minus 1 by s into s plus 1. Let us solve for k here. So, after substitution of the data, k becomes minus 10. Substitute here. S place 0, minus 1 by 1, that is minus k equals to 10. K is minus 10. So, we got k value as minus 10. So, do partial fraction expansion, take its inverse Laplace. So, s place 0, what will be the residue? If you take s place 0, the residue will be 10. If you take s as minus 1, it will be minus 20. So, what is the inverse Laplace of the given data? Given expression is 10 ut, 1 by s is ut, this is 20 e power minus t u of 10 ut minus 20 e power minus t. From the given data, write Laplace expression. This is the condition given, final value must be 10. To satisfy that condition, k must be adjusted as minus 10. Then we got the answer. This is one way of answering. From the given options also we can observe that. From the given options, check where the final value becomes 10. A, B, no chance. If you substitute t as infinity, of course C also no chance because e power infinity is infinity. But if I substitute here t as infinity, e power minus infinity is 0. We are left with 10. That is what our expectation. Without all this mathematics, from the given options also we have chance of deciding what is the valid result. Hope the point is clear. Very simple model. Adjusting that k factor is important here. Okay. Let us see the next model. What is the Fourier transform of x of t equals to 2 into pi of t minus 3 by 2. Pi t is a rectangular pulse. Normally, we are representing rectangle as two different symbols. One symbol is a rect t by capital T. Another way of representing that is a into pi of t by t, for which the standard Fourier transform answer is at sync ft. So, here x of t is given as, let us name that as y of t minus 3, where y of t is taken as 2 into pi of t by 2. I am assuming 2 into pi of t by 2 as the standard reference signal, where 2 into pi of t by 2 will cover that rectangle extends from minus 1 to 1 having amplitude 2, extra 2 is there, 2 into pi of t by 2. So, what is the standard spectrum for this based on the formula at sync ft? T value 2, a value 2. So, what is the standard Fourier transform? You can write 4 sync 2f, at sync ft. Compare at sync ft, 4 sync 2f. Here additionally it is application of time shifting property, t naught equals to 3. Normally what is time shifting we can say in Fourier domain? E power minus j2 pi f t naught y of. So, once you take Fourier transform here, x of f is e power minus j 2 pi f. T naught number is how much? 3 into yf. But what is y of f? As we are assuming this as y of t, this is y of f. So what will be the new result? 4 sinc 2f into e power minus j 6 pi f. Option B. Very simple. Pi of t is the rectangular pulse. We habituated to represent in this style a rect t by t or a times pi of t by t. Take its spectrum, standard formula, later on application of time shifting property. Okay. Let us see the next model. Let us see the 2 marks questions. Again, it is asked for what is the Fourier transform of sin pi t into pi of t minus half. Just now we observed pi t is what? Pi of t is nothing but a rectangular pulse. Okay. Pi t covers from minus half to half. Pi of t covers from minus half to this is pi of t. What is the meaning of pi of t minus half? It covers from 0 to 1. Take Fourier transform of pi of t minus half. For this, the fixed answer is sinc f. At sinc f t relation sinc f. So here sinc f into e power minus j 2 pi f t naught. T naught is 1 by 2. Shift of 1 by 2 units. Because this rectangle is right shifted by half to generate this signal. So for convenience, let us name this as yt, this as yf. So you can write x of t as y of t into sin pi t, y of t into sin pi t. We are assuming this segment pi of t minus 1 by 2 as y of t. Any signal generally multiplied by sin or cos function is application of frequency shifting property or modulation property. What is it? Y of t e power j 2 pi fct is nothing but y of f minus fc. Any signal generally multiplied by sin or cosine function is indication of applying frequency shifting property. Expand sign in terms of exponent, try to apply the property. So further it is taken as y of t into sin pi t expansion is e power j pi t minus e power minus j pi t divided by 2j. But as we are solving with f symbol, what is our expectation in the exponent? E power j 2 pi fct form. So let us make that adjustment. So this is adjusted as e power j 2 pi into 1 by 2 into t, one term, e power minus j or minus half into t by. So according to property notation here, fc is a plus half, here fc is minus half. So now when you take Fourier transform here, what is the result we are going to write? Y of f minus half minus y of f plus half divided by 2j. Y of f minus half minus y of f plus half divided by 2j. But what is yf we have assumed in the last slide? Sinc f into e power minus j pi f. This is nothing but sinc f into e power minus j. So we are left with mathematical simplification. So there we are substituting. So further it is 1 by 2j First time f is replaced as f minus half. So sinc of f minus half e power minus j pi f minus 1 by 2 one term. What is the second term? Minus sinc of f plus 1 by 2 e power minus j pi into f plus 1 by. Here we are getting two extra quantities. Here the extra term is like e power j pi by 2, here e power minus. E power j pi by 2 is simplified as plus j. E power minus j pi by 2 is simplified as minus j. So further it is taken as what? Further it is taken as what? Here we have e power j pi by 2 extra, so j times sinc f minus half, okay. E power minus j pi by 2 is minus j, minus into minus becomes sinc of f plus half whole divided by 2j. This is extra multiplied by one common term. What is it? E power minus j pi f. Extra j terms cancellation. Extra j terms cancellation. So see what you are left with after cancellation of extra j. Sinc f minus half plus sinc f plus half divided by, just a minute, I have to cancel. So sinc f minus half plus sinc f plus half whole divided by 2 into exponent. So that will look like which option? I think option B. Option B is the very simple question. Slightly you may feel lengthy, but the thought you need is application of which property. Pi of t is the standard rectangle for which this is the spectrum, which is right shifted by half. Later on signal multiplied by sin or cos is modulation property. In simplification, have patience for getting the solution. You must be careful. That will look like option B. Correct or not? Option B. So let us see the next model that is asked as 2 marks question here. Very good question. The power spectral density of phi cos 200 pi t plus phi cos 200 pi t into cos 30 pi t. We are expecting the power spectral density. Power spectral density of periodic signals, we have a standard formula for which first we have to calculate the Fourier series coefficient. What is the general Fourier series coefficient? Sigma minus infinity to infinity Cn e power j 2 pi n f naught t, n omega naught t, that is nf naught into t. So first try to write the Fourier series representation of the given function. Here we need an adjustment 2 cos A cos B style. So let me take the fresh slide. So x of t equals to phi cos 200 pi t, that is one term, plus second term can be written as phi by 2 times 2 cos A cos B. Phi by 2 times 2 cos A cos B. So if you make that adjustment, cos A plus B is one term, cos A minus B is the other term. 2 cos A cos B. 200 pi plus 30 pi one term, 200 pi minus 30 pi after adjusting. So the fundamental frequency here is what? GCD of the given numbers, that is 200 pi, 230 pi as well as 170 pi. First try to calculate the fundamental frequency. That will be 10 pi. That will be 10 pi. In radian mode, f naught square, it is 5 Hz. So first let us draw the Fourier series spectrum for this. Let us draw the Fourier series spectrum for this. Try to express in terms of exponent. Expand it. E power j theta 2 pi into NF naught concept. NF naught concept 200 pi can be written as 2 pi into 5 into 20 into t plus e power j 2 pi into 5 into minus 20 into minus 20 into expand it e power j 200 pi t e power minus j 200 pi t. I am writing that like which form? E power j 2 pi nf naught form. Nf naught form. Okay. Similarly, how I can write the next term? 5 by 4 cos expansion 5 by 4 e power j 2 pi into 5 into 23. Another term e power j 2 pi into 5 into minus. One more term we have 5 by 4 e power j 2 pi into 170 pi can be adjusted as this way. Nothing is there. Try to write in Fourier series style. Fourier series style. Where we have fixed f naught number. Fixed f naught 5. Fixed f naught. Okay. So if I try to draw the Fourier series spectrum here. Cn versus n omega naught, that is or nf naught, n into 5. So what amplitude levels I have to draw? At plus or minus 100 it is, at plus or minus 100 it is 5 by 2. Amplitude is 5 by 2. Okay. But at plus or minus 115 as well as plus or minus 85. It is 5 by 4. This is 5 by 4. Okay. So till here the Fourier series spectrum is over for the given periodic function. Cn is over. But what is expected? Power spectral density of periodic signals. For that we have a standard relation. Using that standard relation, simply mod Cn square we should choose. For that sigma mod Cn square we have to choose. So till here we completed Cn. Just a minute. Yes, we completed Cn. Now we want the power spectral density. So the power spectral density of periodic signals. Power spectral density of periodic signals is given by sigma minus infinity to infinity mod Cn square del of f minus nf naught. That is a standard relation. Power spectral density of periodic signals. We are already available with Cn spectrum, magnitude whole square you take. Spectral density spectrum is needed, magnitude whole square. So 5 by 2 whole square, 5 by 4 whole square like that. So if I draw the spectrum, we are having the same impulses but with squared magnitude. What frequency numbers? 85, 100, 115. Squared magnitude means 5 by 2 whole square becomes 25 by 4. Another thing is 5 by 4, 5 by 4 becomes 25 by 16. Mod Cn square. We have to choose mod Cn square. Correct or not? Modulus of Cn square. So that will look like according to the given data, which option you can feel? Option B. For a periodic signal, first we have to calculate Fourier series representation. What is the standard form? Sigma Cn e power j 2 pi nf naught t. Then we adjusted that cos A cos B term with 1 by 2 as 2 cos A cos B. Solve for it. Try to draw Fourier series spectrum. This is the Fourier series spectrum. Once you know Fourier series spectrum, what is the power spectral intensity of periodic signal standard relation? Based on that, we have drawn the new spectrum. Sigma mod Cn square del of f minus nf naught. Standard relation. Very simple question, but have patience in solving that particular model. Okay. Let us see the next model we are having. This is a DFT question. Consider the signal x of n equals to set of 5 samples 1, 1, 1, 0, 0 is having 5-point DFT as xk. What is the inverse DFT of this term is asked. Length is 5. Spectrum multiplied by exponent is the indication of applying which property? Circular shift. X of n minus n naught base n is having spectrum as e power minus j 2 pi by n k n naught xk, or we are writing in Wn style also, because that phase factor we are assuming like e power minus j 2 pi by. So let us name this entire quantity as yk 2 pi by 5 into 2 into k into xk. Our length periodicity is 5. So e power minus j 2 pi by n, 4 pi by 5 can be adjusted as 2 pi by 5 into. So once you take inverse DFT here, what is y of n? X of n minus 2 base 5. N naught positive means last 2 samples to the beginning. We have to pick last 2 samples to the beginning. Correct or not? Try to pick the last 2 samples to the beginning. Okay. That will look like this option. Option D. Very simple. Spectrum multiplied by exponential. Spectrum multiplied by exponential indicates application of circular shift property. Try to pick the last 2 samples to the beginning. That is the answer. Okay, these are few questions that were asked in signals. All the best for you.
Go with the very first question under pre-gate. Okay, dear students, have a look. One curve of an n-channel MOSFET is characterized by the following parameters. So he has clearly specified this is an NMOS, and a VA characteristics was clearly specified, and VGS versus ID. Okay, and you know what he has given. VDS at is a 4 volt and the threshold voltage is 0.8 volt. Then what is the value of conduction parameter? Students, if you check it out, VDS at which is nothing but 4 volt. I hope you know VDS at is nothing but VGS minus VTH. And ID sat, you know, he has given clearly as a 2 into 10 power minus 4 ampere. So ID sat value how much, guys? 2 into 10 power minus 4 amps. Am I right? Yes. So threshold voltage he has given, which is 0.8 volt, which is a 0.8 volt. Then what is the value of conduction parameter? That is process transconductance parameter. We say Kn. Kn is how much? Which is nothing but microamps per volt square. So, okay. Now, let me know, my dear students, we know the formulae ID sat. If I take it as an ID sat, it is nothing but what here? Kn into, you know, VGS minus VTH whole square. Why? Because if no condition is given, early voltage we need not to be considered. So therefore, you know, ID sat he has given, and VGS minus VTH is nothing but VDS sat. My God, this is very easy question, man. So directly you can substitute 4 square here. Am I right here? and ID set, you can substitute, you can easily get the value for Kn. So the answer for the given question will be almost like a 12.5 microamps per volt square, right? Next, this is very interesting question. Most of the parts we have discussed in the class itself, okay dears. So consider an N-type silicon photoconductor with the length he has given, okay, photoconductor length, very important, area of cross section, minority lifetime and applied voltage. Then calculate the photoconductor gain, okay. So how can we do that? So try to recollect what we have discussed clearly, and directly we can use the photoconductor gain, okay, depends on the lifetime, depends on the transit time, depends on the mobility. Am I right, dear students? So it is like tau by t, where tau is a lifetime and t is a transit time, into 1 plus mobility of electrons by mobility of holes, like that. Then you can easily find, the time with respect to the drift velocity formulae as per the given data, you can get the answer. So, tau p by Tn into 1 plus Vp by mu n. What is that, dear students? Photoconductor gain. Am I right, everybody in the class? And of course, the transit time depends on the length, with, I mean to say, what length the particles are getting propagated. If it is BJT, the length from emitter to collector, what length the carriers are getting propagated. If from emitter to collector, if they are going, we are supposed to consider the length as a base width. Am I right, dear students? Right? Don't forget what you have studied already in the previous classes. And electric field I can represent as voltage per length. So L squared by V into 1 by mu n. Substitute the value of length he has given, applied voltage and a mobility of electrons. I think everything examiner has clearly specified over here. So if you can find Tn, substitute that Tn, you can easily get the value for gain, and by solving you will be getting 1.83 into 10 power 2. Consider a silicon semiconductor at room temperature in which Na he has given, Nd he has given. Guys, you please let me know, whenever Na, Nd both are doped onto the same silicon material, I understand that will be a compensated semiconductor. And Na 10 power 16, Nd 3 to 10 power 15, clearly showing that acceptor doping is greater than donor doping. So it is a p type. So the semiconductor will be what here? P type. Therefore P naught. Because we are supposed to calculate the majority concentration of carriers under equilibrium. Very simple answer. P naught is equals to Na minus Nd by 2 plus root of Na minus Nd whole square plus Ni square. That's it. Excuse me. Am I right, everybody in the class? Where for silicon, Ni for silicon at a 300 Kelvin is how much, guys? 1.5 into 10 power 10 per centimeter cube. So if you could substitute that and solve, you could be getting this answer 7 into 10 power 15 per centimeter cube. So my dear students, one more very interesting question. Consider an N-channel MOSFET with width and length he has given, Cox dash, he has specified oxide capacitance per unit area. I think it must be a farads per centimeter square, Cox dash, okay. And assume that the drain current in the non-saturation region, clearly specified that it is a non-saturation, indicates it must be a linear. And moreover, he has specified that VDS is 0.1 volt and ID is equals to VDS. So at VDS equals to 0.1 volt, itself shows that very small value. I hope if it is very small, we can consider this as a deep triode. Originally, in a triode region, you can understand the formula. ID is equals to mu n, Cox dash double by L into VGS minus VTH into VDS, right? Minus half VDS square. This is in a triode. Am I right here, everybody in the class? Whereas ID is equals to mu n Cox dash double by L into VGS minus VTH into VDS. Whereas this is deep triode. Am I right here, everybody in the class? Okay, so interesting thing here is they have given different VGS values and we are supposed to calculate the inversion carrier mobility. So we are supposed to find electron mobility here. So do one thing, you just subtract, for example, take it as ID1, mu n Cox dash double by L VGS 1 minus VTH into VDS. Take it as ID2, mu n Cox dash double by L into VGS 2 minus VTH into VDS. Then why don't you subtract both such a way that you can go for ID2 minus ID1, and I hope you can solve it. By solving both, you can easily find the value for mobility. So by solving both, you'll be getting ID2 minus ID1 as mu n cox dash WBL into VGS2 minus VDS1 into VDS, which is common. So by solving, you'll be getting around 773 centimeter square per volt second, which is the mobility. So one more very interesting question, guys. Determine the impurity doping concentration in a P plus N junction shown in the figure. Assume built-in voltage, slope, okay, slope he has given, and operating temperature, yes, the data he has given. Now we are supposed to find the impurity doping concentration. So the examiner not specified it should be doping concentration of P side or N side. That means we need to find ND or NA. We really don't know. Then what should I do? What should I do? Slope he has given, CV characteristics he has given. What should I do? Then do one thing. I have only one choice. Students, capacitance he has given, that to C dash. C dash is equals to epsilon of silicon by depletion width. Am I right? Excuse me. Depletion width. What is that? Formulae under root. 2 epsilon by Q. It is P plus N. Therefore, it is ND into built-in voltage plus diode voltage. Hello, correct or not? Everybody in the class? Yes, built-in voltage. Slope he has given respectively with operating temperature. Yes, I think this is correct. Built-in voltage plus diode voltage, because it is a junction voltage you are going to get. Built-in voltage plus diode voltage you can go. Right, dear students, everybody. Now, please let me know. So, the same expression, can I write like this? C dash square, then epsilon of silicon whole square, whole divided by, here what I am going to get? 2 epsilon of silicon by Q into 1 by ND into, it will be what here? VBI plus VD. VBA plus VD. I think this must be the junction voltage he has given in the x-axis, because diode voltage is not specified. Indicate junction voltage. This junction voltage must be VBI plus VD. That must be the x-axis. That must be the only choice we have. Okay. So, anyways, you got this point here. Therefore, could you please let me know, guys, boys and girls, everybody, what is C dash square? What I'm going to get? So, it is square and epsilon will be nullified. So, Q times ND into VBI plus VD whole divided by, whole divided by 2 times, I'm sorry. Yeah, what I got here, Q times ND epsilon of silicon, Q times ND epsilon of silicon whole divided by 2 times right, VBI plus VD. That's it. So this is what exactly we got as a C dash square. Now I need a 1 by C dash square. So 1 by C dash square. Now speak out, guys. Therefore 1 by C dash square. It will be how much, guys? So 2 into VBI plus VD whole divided by Q times ND epsilon of silicon. I think it is like a straight line. So it is like y is equals to m into x plus c. Correct? Therefore, I am happy to say I can get the slope. M is equals to, so this is y-axis and x-axis is VBA plus VD. So slope will be 2 by Q into, so 2 by Q into ND into epsilon of silicon. Oh, what a beauty. And I think examiner might be giving the slope. Did he give? Did he provide the slope? Yeah, slope 6.15 into 10 power 15 farads per centimeter square whole power minus 2 volt inverse. Yes, the slope he has given. If you can substitute that slope, I think you will be getting the ND value. So this is the value we got ND, 1.96 into 10 power 15 per centimeter cube. So 1.96 into 10 power 15 per centimeter cube indicates, I believe option D must be right. Wait. Don't say my answer is completed, okay? Why? Because he is asking doping concentration indicates we got ND. Can I get NA? Any other choice we have? Yes. How, sir? We have a built-in voltage. built-in voltage, I think he has given 0.725 volt is equals to kT by Q, log mod ND NA by NA square basic. I think examiner has given the value of Ni. Substitute there everything. I hope you can easily get the value for Na per centimeter cube. So if you can check it out, the value for Na, it is almost 1.64 into 10 power 17 per centimeter cube. 1.64 into 10 power 17 per centimeter cube. So option A. Therefore, the final answer is option A and option D. I understand this is a multiple select question. Very brilliantly examiner has framed this question, right? Consider one more interesting question, guys. Under N-channel silicon MOSFET, that means NMOS, temperature 300 Kelvin, substrate is doped to, that means P substrate, and torques, okay, body to source voltage, which is very practical, and find the change in the threshold voltage. Fine, man. Have you remembered the formula, guys? Threshold voltage formula with respect to the body effect, that means VTH naught. Threshold voltage without body effect plus gamma into root of, so source to body voltage plus 2 phi f, right, minus root of 2 phi f. That's it, guys. Okay, and I hope you know the value of gamma. Gamma is equals to under root, 2 epsilon of silicon Na, correct, into Q whole divided by Cox dash. What is Cox dash? Cox dash is nothing but epsilon naught epsilon r of silicon dioxide by torques, and epsilon r of silicon dioxide is 3.9 and epsilon r of silicon is 11.7. I think everything you got. So end of the day, what we are supposed to find? VTH minus VTH naught, which is called as a delta VTH. That is what we need to find. So everything I have done here. So 2q epsilon, that's what I have done. 2q epsilon, Na by Cox dash. All the values we got, phi fp we got, Cox dash we got. If you can substitute, if you can solve it, you'll be getting 0.264 volt. Okay, lot of numericals we have done in the class. Correct, or not, dear students? And moreover, the phi f. What is phi f? Phi f is Fermi potential. What is phi fp? Which is nothing but kT by q, log mod Na by Ni basic. So everything is based on your calculation. Accordingly, you please manage your time. Calculations are very, very important. Okay, dear students, you please check out the answer. You will be getting 0.264 volt. Okay, dear, best wishes.
Hello friends, let us look at pre-gate analog circuits solutions now. Go through the question once. Neglect the channel length modulation. The MOSFET given are similar and have a transconductance GM. Calculate the voltage gain. Go through the question. Now the given MOSFET are similar. Similar meaning both have the same GM, and since the channel length modulation is neglected, you can neglect R0. You can neglect R0. So voltage gain is a AC parameter. Voltage gain is a AC parameter. So let us draw the AC equivalent. For AC equivalent, we have to kill the sources. The DC sources are removed here. Current sources are replaced by open circuit, and voltage sources are replaced by short circuit. Okay, so this Vn is distributed as VGS1 and VGS2. And here you have ID1 and ID2. So this is the AC equivalent. Now we are asked to find V0 by Vn. There are two ways. One is you can do by the small signal model, or directly you can write the Kirchhoff's laws. You can write the Kirchhoff's laws. But Before we write Kirchhoff's laws, try to understand that in a differential amplifier, there is symmetry. Symmetry meaning this VGS1 is minus VGS2, the ID1 is minus ID2, So VGS1 equal to minus VGS2 equal to VGS, and ID1 equal to minus ID2, you can treat it as ID. So let us write Kirchhoff's laws now. So what is ID2? ID2 is 0 minus V0 by RD. ID2 is 0 minus V0 by RD, or V0 is minus ID2 into RD, or minus ID RD. V0 is minus ID RD. What is Vin? Vin, if you apply KVL, Vin is minus Vin plus VGS1 minus VGS2 is 0. So substitute VGS1 equal to VGS minus VGS2 as VGS. So Vin is 2 VGS. So if you do V0 by Vn, you will get the solution. If you do V0 by Vn, you will get the solution. Now you can see minus ID2 is nothing but plus ID. Minus ID2 is nothing but plus ID. So take the ratio V0 by Vn. V0 by Vn is ID RD by 2 times of VGS. 2 times of VGS. So what is ID by VGS? It is GM. GM by 2 times of RD. This is the voltage gain. So let me, or you can replace the MOSFET by the small signal model and do it. But if you know that in AC analysis, ID is GM times of VGS, then just by writing Kirchhoff's laws, you can do it. Or otherwise, it is a simple problem. If you take left side, the gain is minus GM RD by 2. If you take right side, it is plus GM RD by 2. If you take the difference, it is going to be minus GM RD. If you take the difference. Now, this is taken as the single-ended output. So, it is going to be half of the total differential output. So, the differential output is minus GM RD. This is plus GM RD by 2. So, option D is the solution. Option D is the solution to this problem. Okay. Now, let us go for the second problem. The transconductance of the MOSFET is GM and the small signal drain to source resistance due to the channel length modulation is R0. Calculate the overall output resistance of the amplifier. So, you are asked to find the overall output resistance of the amplifier. The examiner is saying that there is a resistance R0 here. So, you can replace the MOSFET by the small signal model and do it, right. So, let us do it. The small signal model is a basic Norton equivalent. You have GM VGS in parallel with R0. So, this is gate, source and drain. And you can see from the source to ground, there is an RS resistance. And let us apply a test voltage here, V, and find current I. So, output resistance is V by I. Output resistance is V by I. So, now in order to find the ratio V by I, so this current I, which is the entering current, is the same as leaving here. Leaving, since no current flows through gate terminal. No current flows through gate terminal. So, let us finish this. According to Kirchhoff's voltage law, VGS plus I into RS is 0. So, your VGS is minus I into RS. Minus I into RS. So, now let us apply a KVL here, or for simplicity, if this is source, this node is also source, this node. So, if you do not want a resistor here, you can as well draw it here also. You can as well draw it here just for your simplicity, right? Otherwise, you can put a resistor here. You have to apply KVL like this. The same node is this. So, I just connected the same resistor here. Just think it, this is the image of this, right? So, here if you apply KVL, you can finish the problem. So, let us apply KVL. Minus V plus I minus GM VGS into R naught plus I into RS is 0. So, minus V plus I into R naught minus GM R naught into VGS. VGS is minus IRS plus IRS equal to 0. So, what is V by I? V by I. So, you can take I common here. I common, it is going to be R naught plus 1 plus GM R naught into RS. So, this is the output resistance, RS plus GM R naught. So, option D, it is R naught plus RS plus GM R naught into RS. This is the output resistance. Now, you can extend this idea to any number of MOSFETs. For example, of course, the solution is done here, but instead of RS, if the examiner gives an additional MOSFET here, additional MOSFET, so this becomes the cascode amplifier. Then you can have an R naught here, R naught 1, and this one you can take it as R naught 2 and do it. So, now what will be the problem? It is R naught equal to R naught 1 plus GM1 R01 into this RS. What is the value of RS? It is R02. Like this you can do it. So, now you can extend any number of MOSFETs. So, this whole output resistance is the output resistance of the overall cascode amplifier, and this RS is replaced with R02, right. So, like this, and this is approximately, this factor is larger. So, GM1 R01 R02, like this also you can approximately. So, this is the solution. So, simple, calculating output resistance by Ohm's law is V by I. V by I, apply a test voltage, find the current drawn. Now, go through the problem. An op-amp has an open loop gain of 7, its differential input resistance is 10K, and the output resistance of 0 ohms is given. Calculate the closed loop input resistance. Calculate the closed loop input resistance. You can solve this problem by replacing op-amp with an equivalent model, or you can do this by simple Miller's theorem also. Miller's theorem, because Miller's theorem states that if you have an amplifier with an input node V2 and output node V0, and V0 is A times of V1 minus V2, and how much is A? A is 7, V2 is V2. So V0 by V2 is going to be minus 7. V0 by V2 is going to be minus 7. So now what happens if a resistance is put between input and output? Now this resistor can be split into two resistances. So two resistances. One is called R1 and the other one is R2. R2 is not needed because we are finding at the input side. So R1 is going to be R divided by 1 minus output voltage by input voltage. The output leg voltage by the input leg voltage where the resistance is connected. So this is 10K by 1 plus 7. It is 10K by 8. It is 10K by 8. So that is the resistance R1. Now let us replace the op amp now with this equivalent. The 10K is split into R1 and R2. And mind you, there is also a differential input resistance of 10K, which you should not forget. So let me draw now. There is 10K and there is an R1. And now this op amp also has some input resistance of 10K. And R2 is not needed. So what is the input resistance? The input resistance is the parallel combination of these two in combination with, in series with 10K. So Rn is going to be 10K plus R1 parallel with 10K. This is the solution. It is 10K plus 10K by 8 parallel with 10K. 10K parallel with by 8 parallel with 10K is 10K by 9. So R parallel R is R by 2. R by 2 parallel with R, R by 3. R by 3 parallel with R, R by 4. So 10K by 8 parallel with 10K is 10K by 9. So it is going to be, so it is 10 kilo ohm plus 1.1K. So it is going to be 11.1K. Approximately, let's see the options. Yeah, 11.1, option B. And don't forget that there is a differential input resistance here also, right? Or if you don't want to do this method, you can replace op amp with the equivalent like this. And V0 is, output resistance is 0. It is AVD. So V0, A is 7 VD. So if you don't want to do by that method, you can apply a test voltage V here, find current I. Just like how we have done for that MOSFET problem, you can do V by I, you will still get the same answer, 11.1K. 11.1K, the node voltage here is minus VD and V0 is 7 VD. So you can take some current I1, I2, I3, apply Kirchhoff's laws and do it. Like that also you can do. Go through the problem. Assume the given op amp are ideal. Calculate the output voltage. So this is a simple problem where you can apply virtual short and solve. Try to apply virtual short for this problem and solve. Okay. So what is virtual short? The voltage at non-inverting and the voltage at inverting both are same. Both are same. So, if this is Vx, or you can take this node as Vx, if this is Vy, this node is also Vy. This node is also Vy. And if this node is -1, this is also -1. Since op-amp draws no current, you can apply something called the voltage division. Voltage division. So, what is Vy? Vy equal to V0 into 1k by 3k plus 1k. It is V0 by 4. It is going to be V0 by 4. Or you can take entering current and leaving current, entering equal to leaving. You can apply the KCL at this node. If you apply KCL at this node, you will get the same thing, right? Or you can apply voltage division. Now, what is Vx by superposition theorem? What is Vx by superposition? Vx by superposition, you have Vy here, you have Vx, and there is 2k and 1k and 1 volt. So, again if you want, you can apply Vy here and the nodal analysis you can do, or directly superposition theorem. Vx is going to be, this is a non-inverting amplifier for Vy, 1 plus 2k by 1k into Vy, plus for 1 volt, this is an inverting amplifier, minus 2k by 1k into 1. So, this is 3 times of Vy. How much is Vy? V0 by 4 and minus 2 is going to be Vx. So, Vx is 3 V0 by 4 minus 2 for this op-amp. For this op-amp, again you can apply the same superposition theorem. And what is V0 due to minus 1? V0 is 1 plus 8k by 4k into minus 1 plus due to Vx minus 8k by 4k into Vx. So, what is V0? V0 is going to be 3 into minus 1, minus 3 minus 2Vx. So, we have to find V0. Let's eliminate Vx. Let's eliminate Vx. So, what is Vx here? 2Vx equal to minus 3 minus V0. So, Vx is minus 3 minus V0 by 2. So, let us equate these two and you will get the answer. So, let us equate these two, you will get the answer. So, try to equate them. 3 V0 by 4 minus 2 equal to minus 3 minus V0 by 2. So, this is going to be 3 by 4 is 0.75, 0.75 into 2, 1.5 V0 minus 4 equal to minus 3 minus V0. So, 2.5 V0 equal to 1. V0 is 1 by 2.5, which is 0.4 volt. But is there a point? Yeah. So, your V0 is 0.4 volt. So, let me repeat this. I applied voltage division here for V0, which is 1/4 of V0, because 3/4 is dropped here, 1/4 is dropped here. Your Vy is 1/4 of V0, and you can apply the same V0 by 4 here and minus 1 here. And here I applied superposition theorem, or you can apply KCL. In the solution I have given with KCL. Here I am doing by superposition, just for a change. This Vy is 1 plus Rf by R1 times of Vx is 1 plus Rf by R1 times of Vy, and due to this it is minus Rf by R1 times of that. Similarly, here also the same superposition theorem I applied. I got Vx. I try to equate them for this solution. So this is for op amp, first op amp 1, and this is for op amp 2. Okay. Go through the problem. Find Vc max in steady state if the capacitor has an initial charge of 0 volt and a threshold of 1 volt So, before we solve this problem, the basic logic is for an NMOS to be on, remember the source voltage should be lesser than the gate voltage. The source voltage is lesser than the gate voltage at least by Vt, right? It should be less. And the drain voltage, this source voltage cannot be greater than the drain voltage, because the drain voltage happens to be the supply voltage. This source voltage is always less than or equal to the drain. But there is at least a difference of 1 volt here for the MOSFET to go to on state, right? The maximum voltage the source can get is the drain voltage. So, this is a simple logic here. The first MOSFET you can see has a drain voltage of 9 volt, but the gate is 10. So, you cannot get any voltage here more than 9, and the difference is at least 1 volt has to be maintained. This is the first MOSFET. The second one has a drain voltage of 6 volts. So, the source voltage cannot be more than the drain. And this is again given to the third one. The third one, drain is 10. And here we are connecting a capacitor. So, what is the maximum voltage this capacitor can charge before it makes the MOSFETs to go to off state? So, this is 6. So, this voltage could be maximum 6. It cannot be more than that, right? And now 10 minus 6, you have 4 volt. So, definitely these two MOSFETs are on. But if you take 9 here and make this 8, which doesn't make any sense, any physical sense. You cannot have 8 volt when the drain itself is 6. So, when this is 6 volt, the maximum voltage you can get here is 6. And 6 minus 1, at least 1 volt difference should be there, is 5. So, this capacitor can charge to a maximum voltage of 5. What happens if it charges to 5.00000001? If it charges to 5.00001, then the difference is going to be 0.999999, and the MOSFET will go to off state. So, before it makes the MOSFET to go to off state, this capacitor is charged slowly starting from 0. First it is charged to 0, all the MOSFETs are on. Then it is charged to 1, all the MOSFETs are on. It is charged to 2, all the MOSFETs are on. Once it charges to 5, all the MOSFETs are just on. If it charges slightly more than 5, then the MOSFET will go to off state. So, the maximum it can attain is only 5 volt in this problem. Okay, thank you very much. My best wishes.
Okay, pre-gate ECE, one more question. The longitudinal electric field for TM11 mode is given by Ez is equal to sine 5x sine 8y into e to the power of minus j beta z volt per meter. If the operating frequency is twice the cutoff frequency of the mode, then the value of the phase and group velocities are respectively. So, here what is given is operating frequency is twice that of the cutoff frequency. Fine. Then is asking what is the phase velocity and group velocity. The phase velocity and group velocity, there are some standard formulas. They are nothing to do with the field expressions. Fine. So, what is the phase velocity here? The Vp is equal to V naught divided by square root of 1 minus Fc by F whole square. Clear? Generally, if it is nothing is mentioned, you have to take it as an air field. So, it is 3 into 10 to the power of 8 divided by square root of 1 minus fc by f whole square. So it is 1 by 2 whole square. So check out this value. This value will turn out to be 3.4. 3.46 into 10 to the power of 8 meters per second. Okay. So the phase velocity is 3.46 into 10 to the power of 8. 3.46 phase velocity, option C. Fine. Or if you want to find out the group velocity, you can make use of this formula. So the group velocity Vg is equal to V naught into square root of 1 minus Fc by f whole square. So which is equal to 3 into 10 to the power of 8 into 1 minus 1 by 2 whole square, which is, check out, you can check out, this will be turn out to be 2.59 into 10 to the power of 8 meters per second. So option C is the answer. Okay, pre-gate ECE, one more question. A 6-element uniform array has an inter-element spacing of 0.3 lambda and the progressive phase shift of 40 degrees. The direction of maximum radiation with respect to the axis of the array is. Fine. So the maximum direction formula for uniform linear array is cos phi max is equal to minus delta divided by beta d. Convert this one everything into the radians. So it is 40 degrees divided by 180 into pi into 1 divided by, it is 2 pi by lambda. How much is the lambda? Lambda. So spacing is, it is 0.3 lambda. Fine. You can just cancel out this pi. So you are going to get minus 4 by 18 into 1 divided by 0.6. Clear? So this is equal to, it is minus 2 by 9 into, bring this one into 10 by 6. So which is minus 10 by 27. Correct? Fine. So you can check out this one. You can take the cos inverse here. Phi max is equal to cos inverse of minus 10 by 27. So it is 111. You can check out this value. It is 111. 0.73 degrees is the answer. This is a numerical answer type question. Okay, pre-gate ECE, one more question. A 50 ohm line is terminated in an impedance. The distance between the two consecutive maximas is 30 centimeters. The phase constant of the wave is. Fine. So what is the consecutive maximas or consecutive minima distance is? It is a mirror lambda by 2, which is equal to 30 centimeters. So that means lambda is equal to 60 centimeters. So by definition, what is the beta? Beta is equal to 2 pi by lambda. Yes. So which is 2 pi divided by 60 into 10 to the power of minus 2. Convert into the meters. So check out this value. It is around some 10.47 radian per meter. So it is a numerical answer type question. What is the answer? 10.47 is the answer. Okay, pre-gate ECE 2 marks question. In an ideal dielectric medium, a wave has a electric and magnetic fields given like this. So some following is asking, MSQ question. The value of A is, next one, the phase constant of the wave is, velocity of the wave is, the frequency of the wave is. Fine. So let us try to address this one. First you need to find out the wave vector here. So what is the wave vector? By looking at this one, the wave variable, you can write the wave vector. Fine. So what is the wave vector here? The wave vector here is, you can write this one in the like this. So the wave vector, so the K is equal to, you can take the minus common and there is a magnitude here, you can write in the, so it is pi into x cap plus pi into z cap. So this is a wave vector. Fine. And if you take the unit vector of this, so the k cap is equal to vector by its magnitude. So this is pi x cap plus pi z cap divided by square root of pi square plus pi square. So it is k cap is equal to x cap plus z cap by root 2. Fine. So what is the first part of the question? The value of the A is, So if it is for the uniform plane wave, the first one let us try to address. For the uniform plane wave, h vector dot k must be 0. There should not be any component along the direction of propagation. So what is h vector here? It is ax cap, you can just discard this part, plus jy cap plus z cap dot product with x cap plus z cap by root 2 must be equal to 0. Okay, there should not be any component. So perform the dot product here. So this dot this. So a plus this one dot this one is 1, which is equal to 0. So a is equal to minus 1. But what is said in the question? The value of a is 1. So wrong. Next one, the phase constant of the wave is pi root 2. Let us see what is the phase constant. Number 2. Suppose if you take the magnitude of this k, that itself is a phase constant. Fine. So phase constant beta is equal to magnitude of the k, which is square root of, it is pi square plus pi square, pi square plus pi square. So which is beta is equal to pi root 2. Units are radian per meter. Fine. Let me go back here. So option B is the answer. The phase constant of the wave is pi root 2 radian per meter. Let us try other things. The velocity of the wave is 3 into 10 to the power of 8. Let us see. So let us try to find out the velocity of the wave. So there is a beta here. Now let us check. He said what is called a dielectric. Okay. What kind of dielectric he has not said. It is not a magnetic field. That is what we can do. Now let us take the magnitude of the electric field to the magnetic field. So if I take the ratio of electric field to the magnetic field, it must be equal to eta, which is equal to square root of mu naught divided by epsilon naught epsilon r, because it is the dielectric. So what is the magnitude of E? It is square root of 1 plus 4 plus, here magnitude is 1, divided by what is the magnitude of H? It is a square. A value is minus 1 we have got from this discussion. So it is a minus 1 square is a square root of 1 plus this one is 1, magnitude is 1, this one is 1, divided by 60 pi, which is equal to 60 pi, it is square root of 6, square root of 3, it is square root of 2, which is equal to 120 pi divided by square root of epsilon r. So square root of 2 is equal to 2 divided by square root of epsilon r. So square root of epsilon r is equal to square root of 2, epsilon r is equal to 2. Fine. So if the epsilon r is equal to 2, what you can have? What is the velocity? Phase velocity is 1 by divided by square root of mu naught epsilon r, which is 3 into 10 to the power of 8 divided by square root of epsilon r is 2. So which is not equal to 3 into 10 to the power of 8 meters per second. So it is not free space, one can say. Option C is not correct. The frequency of the wave is 2.21 into 10 to the power of 8. Let us check. So let us try to understand the frequency from the beta. Beta is equal to omega square root mu naught epsilon r. Clear? So which is equal to, we have got a beta from here, it is pi root 2. Fine. So this is equal to 2 pi f divided by 3 into 10 to the power of 8 into square root of epsilon r is 2, which is equal to pi into square root of 2. Now f is equal to, you can check it out, root 2 will cancel out, pi will go, it is 3 into 10 to the power of 8 by 2. So it is 1.5 into 10 to the power of 8 meters hertz. 1.5 into 10 to the power of 8 hertz. But what is given option D is wrong. So only option B is the correct. Pre-gate ECA 2 marks question. A rectangular waveguide of 4 by 3 centimeters cross section carries the dominant mode at 6 gigahertz. The maximum peak electric field measured inside the waveguide is 50 volt per meter. the power carried by the waveguide in a milliwatts is. Fine. So, what is the formula here? Here it is, power is equal to E magnitude square divided by 4 into eta TE10 into A into B. Clear? So, first you need to find out this one. It is a peak electric field. So, what is this eta TE10? Eta TE10 is equal to 120 pi divided by square root of 1 minus Fc by F whole square. Operating frequency is given 6 gigahertz. You need to find out cutoff frequency for Fc TE10, which is equal to 1 divided by 2 square root of mu naught epsilon naught into 1 by A. So, which is 3 into 10 to the power of 8 by 2 into 1 by A. What is the A? 4 centimeters. 4 into 10 to the power of minus 2. So, it is, you can check out, this is 3.75. It is 3.75 gigahertz. Okay, fine. So, once you have got this one, you can find out eta TE10, which is equal to 120 pi divided by square root of 1 minus Fc by F whole square. What is Fc? 3.75 gigahertz. It is 3.75 gigahertz divided by F. It is 6 gigahertz whole square. So, which is equal to, you can check out, it is 482.68 ohms. So, this is the intrinsic impedance of TE10 mode. Once you have got this one, you can substitute here. So, it is, power is E magnitude. What is the E? It is a 50. 50 into 50 whole square divided by 4 into 482.68 into A into B. It is 4 into 3 into 10 to the power of minus 4. Okay, you can check it out. So, this will be equal to 1.5 into 10 to the power of minus 3 watts. Okay, he is asking in the milliwatts. Yes. So, the W is equal to 1.5 milliwatts. So, what is the answer here? 1.5 is the answer. Okay, pre-gate ECE 2 marks question. What should be the minimum spacing required between the two element array of isotropic antennas, which is used to get the maximum radiation and null along the axis of the array in the opposite directions? Fine. So, let me take some rough diagram here. There are the two arrays here. Fine. So, we want to get the maximum radiation this side and null other side. Fine. So, the maximum radiation on the and null on the opposite direction. So, let us say here phi is equal to 0 max, and where I want to have a null at phi is equal to phi. So, what is the array element here for the two element array? It is psi is equal to delta plus beta d cos phi. Fine. So, what is the condition for the maxima? For max, I wanted to have a maximum at phi is equal to 0. And what is the condition here? Psi by 2 must be equal to 0. Fine. What is this psi by 2? It is delta plus beta d. So, in the case of phi, you need to substitute the 0. So, which is 1 by 2, which is equal to 0. So, delta plus beta d is equal to 0. Let me call this as equation number 1. Similarly, I want to have a null at phi is equal to opposite sides, isn't it? That side maximum, this side null. So, what is the condition for the null? For the null, phi n is equal to pi. So, this is psi by 2, which is equal to plus or minus pi by 2. So, psi is equal to plus or minus phi. What is this psi? It is delta plus beta d cos phi is nothing but minus 1, which is equal to plus or minus 1. Okay. So, it is minus beta d, which is equal to plus or minus phi. Let me call this as equation number 2. So, it is asking for the distance. Fine. equation 1 and 2. I will subtract equation 1 minus 2. 1 minus 2. So, what is that equation 1? It is delta plus beta d minus this one. So, it is delta plus beta d minus delta minus beta d, which is equal to minus or plus phi. Clear, guys? So, this will become minus delta delta will cancel out. This will become, it is 2 beta d, which is equal to minus or plus phi. So, it is 2 into 2 pi by lambda into d. So, it is minus or plus beta d. So, you can bring this one here, cancel out the pi on both sides. So, it will become minus or plus lambda by 4. So, observe the options here, lambda by 4. Option B is the answer. Option B is the answer.
Right. Let us see the solutions given for your questions in pre-gate examination 2025. Let us take about the communication part. I will deal with the communication systems. Let us see the first question, 1 mark bit. Consider a DSBSC modulated signal given by that expression. So, this is simple product of message with carrier, and message I have given as combination of two single tone signals. One is having 1000 hertz component and the other is having a 3000 hertz component. Question is, what is the total power of the modulated signal? So, very simple, just to take the modulated signal in complete expression. So, what is S of t? You will get a 200 cos 2 pi fct multiplied by cos 2000 pi t. I am just substituting m of t there, that is it, plus second message signal is cos 6000 pi t. So, it will be 100 cos 2 pi fct multiplied by cos 6000 pi t, that is all. So, basically you are assuming that fc is much greater than fm. So, there is no condition for that expression also. We have to assume that whenever we perform modulation. So, if you simplify this, you can express this as 100 into cos of 2 pi fc plus 1000 t plus 100 into cos of 2 pi fc minus 1000 t, first upper side band and first lower side band. Similarly, you will have 50 into cos 2 pi fc plus 3000 t. This is representing second upper side band and then second lower side band, 50 cos 2 pi fc minus 3000 t, finish. Now, question is only relating with powers, no need to draw any spectrum. These are all periodic cosinusoidal function, RMS value square will be the power. So, what will be the total power? For the first upper side band, 100 by root 2 whole square, and the same component will have the power in lower side band also. So, you can just simply multiply with 2. Similarly, 50 by root 2 whole square, this is the power present in a second upper side band, multiply it with 2, that will be the power present in a lower side band, finish. So, you will get a 100 square plus a 50 square. So, it will be 10 to the power of 4 plus 2500, or you can express this as 10,000 plus 2500 means 12,500, or you can write it as 12.5 kilowatts, finish. Is it clear or not? So, this is how simple logic you can use. No need to go too much in depth, and do not write any spectrum here. If you write spectrum unnecessarily, you are making lot of mistake. So, this is how you can get your result very quickly. Okay, right. Let us see the next one. Here I have given expression for an angle modulated signal. Okay, what is the peak frequency deviation in kilohertz? So, if you take an angle modulated signal, peak frequency deviation I want a delta Fi of t first, instantaneous frequency deviation. It is 1 by 2 pi into d by dt of delta theta I of t. First order derivative of instantaneous phase deviation divided by 2 pi will give you instantaneous frequency deviation. So that means this will be 1 by 2 pi into d by dt of, what is instantaneous phase deviation? The component that comes immediately after carrier frequency. So this becomes 4 sine 2000 pi t. So this delta Fi of t will be equal to 1 by 2 pi into, you will have 4 into, when you take a derivative of sine you will get cos, and the 2000 pi t derivative will become 2 into pi into 10 cube I am writing, okay, into cos 2000 pi t. So what will be this value now? 2 pi and 2 pi will get cancelled. You will have 4 into 10 cube into cos 2000 pi t. So this is the instantaneous frequency deviation for the given angle modulated signal. Now I want delta f max. So you just take the maximum value of this function. It is 4 kilohertz. That's all. That is our answer. Is it clear or not? So the peak frequency deviation in kilohertz is dash. Its value will be 4. Next. This is also 1 mark bit. The capacity of a Gaussian channel having a bandwidth of 50 kilohertz and an SNR of 23 dB in kbps will be dash. So what is the formula we have to use here? Channel capacity is equal to B into log 1 plus S by N to the base 2. So this is the formula which will give you the capacity of the channel in bits per second. So don't forget that base is not to the 10, it is base log is base 2. So bandwidth of the channel is given to you as 50 kilohertz into log of 1 plus S by N is 23 dB. 23 dB means 10 power 2.3. Substitute normal value to the base 2. Now you can use the calculators here and determine what is this value. I am just using my mobile for that purpose. 10 to the power of 2.3. Be very careful with these numericals, okay, plus 1, and for that you have to take log to the base 2. I got 200.5, so log 200.5, you have to take it to the base 2, okay. So I am getting 7.647, 50 into 7.647. into, anyhow he asked in kbps, so you keep that 10 cube as it is. So you multiply this with 50, you will get 382.37 kilobits per second, that's all. So you can go with that option of 382 kbps. So this is how you can solve these numericals. So all these are 1 mark bits, basically based on the formula. 1 mark bits mostly when they come, it will be relating with the formula only, little bit of deviation might be there. These are all direct bits. Here also there is nothing very special, and here also just substitution only in your modulated signal expression. So this is how you can get your answers very quickly, okay. Next, now let us see these 2 marks questions. From here you are having all the 2 marks bits. These are also mostly conceptual based questions. It may not be directly using the formula, but you have to use a little bit of conditions and get the results. See these bits. In an additive weight Gaussian noise channel with noise power spectral density n0 by 2, means the power spectral density of additive weight Gaussian noise, two-sided power spectral density is given, is having 2 equiprobable messages. So this is a representation for S1 of t and this is a representation for S2 of t. That means basically when you refer S1 and S2, any standard textbook, they refer to this as bit 1 and bit 0. So this is the representation he is taking, okay. Considering use of optimal receiver, what is the meaning? He is using optimal receiver means he is using optimized value of threshold voltage. So when you use optimized value of threshold voltage, what is the formula for probability of error? The probability of error will get minimized. Formula is Q of root over ED divided by 2 into N naught. So this should come into your mind first. And what is the ED? ED is nothing but energy of difference of two transmitted signals, S1 of t and S2 of t. So this is based on this logic. So this hint, how you will know? Based on this statement, because he is using an optimal receiver. The probability of error P at the output of the receiver will be dash. Simple. So you first find that ED. So what is S1 of t and S2 of t difference? If you take S1 of t minus S2 of t, so this value is equal to how much? In 1 bit duration, 0 to t. First signal is AT by capital T minus, when you take a difference, it is minus A, minus of minus will become a plus A small t by capital T. Correct or not? That means, what will be this function now? S1 of t minus S2 of t will be equal to 2 capital A small t by capital T minus capital A in 1 bit duration. That's all. So this you have to get it clearly. Okay. So what is this ED now? Energy of this function. Energy means what? Integral. You are doing in 1 bit duration. Square of this function means 2A small t by capital T minus capital A whole square dt. That's all. Okay. So what will be this value? It will be equal to integral, limit is from 0 to t, expand 4 capital A square by capital T square into small t square dt plus integral, again limit is from 0 to capital T, the second term square is A square dt plus what will be the third term? Minus 2 integral 0 to t. When you multiply these two terms, you will have 2 capital A square small t by capital T dt. That's all. A square term, B square term and 2AB term. Is it clear? Okay. Now, what is this value? It will be equal to 4 capital A square by capital T square. Integral of t square is t cube by 3. When you substitute the limit, it becomes capital T cube plus this is A square capital T minus 4 capital A square by capital T. Integral of t is t square by 2. When you substitute the limit, it becomes capital T square. That's all. Now simplify for this value. What will be this ED? I am just writing here. Here you are having a 4A square into 1 capital T will be remaining by 3. Okay. 1 T square gets cancelled, you will have capital T in numerator, and second term or if you take this value is A square capital T plus or minus, you are having 1 T getting cancelled and you will have 2 capital A square, 1 T will be remaining. That's all. This is the value you will get. So what is this value now finally? Therefore, the value of ED will be 4 A square capital T by 3 minus A square into capital T, or you can write this as A square into capital T by 3. That's all. Over. Is it clear? So this is how you have to find the value of ED. Now it is just substitution in this formula. A square T by, it will become 6 into N naught. So under root A square T by 6 into N naught, that will be your right choice. That's all. It's a 2 marks bit. So whenever these type of questions are framed, try to take which logic he is actually expecting you from you. So you try to understand this point. The entire key is this optimal receiver. Then this is the formula that we have derived for calculating minimum probability of error. So once you get that point, then the remaining part is simple. Generally, S1, S2 will be either cos functions or they may be step signals, but intentionally in this question it is framed in such a way that they are ramp functions. It can be anything, but logic remains the same. Simple calculation of energies and then substitution in these values, that is it. Okay. Let us see the next question. This is also 2 marks bit. See the question carefully. Consider a 8 PSK and 8 QAM. So obviously when you have a PSK, all the points will come on a single circle. When you have QAM, you will get on multiple circles. So he is giving you QAM and PSK 8. Okay. As shown in the figure, both are operating with the same value of d minimum equal to k. So what is this point? Both are operating with the same value of d minimum means the probability of error in first case and second case are same. Okay, obviously that is given by examiner only. You need not worry about that. The relative power advantage of one plot over the other in dB will be dash. That means what is the meaning? When you have 2 different constellation plots, it can be for the same value of m or different value of m, or it can be same modulation scheme or different modulation scheme. So here he kept m same. You see that point? M is 8 here, it is also 8, but he changed the modulation scheme. And what is he saying? The value of d minimum, let us assume d1 here, and the value of d minimum in the second case, let us assume is d2 are same. That means the probability of error in first case and the probability of error in second case are same. So in terms of noise performance, both are exactly same. But what will change? The energy taken by the plots will change. So let us assume this is a energy E1 and this is a energy E2. Total energy taken by first plot and second plot. Definitely they will be different. Now it can be a case where E1 can be greater than E2 or E1 can be less than E2. So one plot will take a lesser energy than the other plot. We generally prefer that plot. So how much is that energy saving that you are doing is what he is asking. So power advantage, energy advantage, all these points are one and the same. Now what is the energy taken by the first plot? You see here very clearly. What is given? He is giving you the radius of the circle as r. So this is given to you as r. So all the points are located on the same circle of radius r. So what is the energy of a single point? It is the square of your circle radius. So for 8 points what it will be? It will become 8 into r square. So what is the total energy taken by the first plot? It is nothing but 8 into r square. Is it clear or not? And what is that ED value here? If you consider this value, you can observe very clearly here. This is your center of the circle. From here the distance measured is equal to r. Square of circle radius is nothing but energy of 1 point. Total energy taken will be equal to 8 into that r square. Okay. So this is let us assume equation number 1. Is it clear or not? Now what about the second one? Second one is having 2 circles. One is a smaller circle having radius a and another one is a larger circle having radius b. Now you have to calculate the energy of the second plot and then relate energy of first plot with energy of second plot. Then you will come to a conclusion which is taking more energy. Now let us try to calculate that value of E1. So for that purpose I am taking this triangle here. I am just considering the center and this point S1 and this point S2. So what will be this structure here? So this is I am just taking that part. So here you are having a totally 8 points. This is my origin. So when 8 points are there, all points are equally distributed on the circle. So angle made between 2 points, 2 pi by 8, it will be 45 degrees. So that means this angle we can write it as 45 degrees. And this is the radius of the circle r. This is also radius of the circle r. So these are my points S1 and S2. So he only gave the d minimum between these 2 points is k. So I am taking that as k. Okay. So use your triangle rule of trigonometry. If you have 2 sides and angle made between the 2 sides, you can find the third side. So here third side is k, so I am writing k square equal to r square plus r square minus 2 into product of the two sides r into r multiplied by cos of the angle made between the two sides, means cos 45 degrees. That's the logic. Two sides and angle made between the two sides of a triangle is given. We can calculate the third side using this logic. Third side square equal to first side square plus second side square minus 2 into product of sides of two values multiplied by angle made, cos of the angle made between the two sides. So what will be this k square now? 2 into r square minus 2 into r square into 1 by root. So you can write this k square as, if you take r square common, you will have 2 minus root 2. Okay. Now my requirement is to find energy. So I need r. So what is this r value now? It will become k by root over 2 minus root 2. That's all. So get that value of r in terms of k. So I am just using my calculator. So this is a 2 minus root 2 and under that it will be root. So 2 minus root 2 and for that you have to take one more root. And for that you have to take inverse. So it will be 1.3066 k, that's all. So what is this even value now? Square of this r, so you can take this square and multiply it with 8. So it will be 13.6588 k square. Finish. Is it clear? So that is how you can calculate the energy of all the 8 points coming on a circle. So when you are given circular pot, there is the advantage, energy will be same. If it is a rectangle pot, you have to take each coordinate and do it. But with circular, the advantage will be there. Now let us see about this 8 QAM. Now 8 QAM you are having a 4 points on inner circle and 4 points on outer circle. So here you can see very clearly these are the 4 points which are there on your inner circle, S1, S2, S3 and S4. Let me take that. So I am taking here one circle. Let us assume this is my inner circle. Okay, and the radius of this inner circle is given to you as A. So this distance is A. Okay. That is what is given here. S1, S2, S3, S4 are there and radius of the circle is A. So these are the points. S1, S2, S3 and S4. Finish. Okay. Now definitely the distance whatever he is talking is d minimum k, so it should be the distance between either these 2 points or between these 2 points. Okay, that is also one very important observation. So whenever you take that d minimum, the d minimum which he is talking is either the distance between these 2 points or it can be a distance between these 2 points. Both will be same, that will not deviate. Is it clear or not? So if you write that value here as the value of d minimum, so this one is your k. Okay, now automatically this is a right angle triangle formed here. So what is this expression? You can write k square equal to a square plus a square. Means you are having k square equal to 2 into a square, or that a is k by root 2 or 0.707 k. That's all. Is it clear? Now what is the energy of these 4 points? Let us assume Ex. Energy taken by 4 points on this inner circle E is nothing but 4 into a square. So it will be 4 into k by root 2 whole square, means it becomes k square by 2, or you can write it as 2 into k square. Is it clear? Okay. Now, if you take the outer circle, so this is my outer circle. Radius of this outer circle is given to you as B. Now, how are these points located? This is the outer circle radius B. You are having S5, S6, S7 and S8. So, let me take that. So, I am having S5, S6, S7 and S8. These are the 4 symbols on this circle. So, again you are having definitely 4 points on a circle, means angle made will be 2 pi by 4, it will be 90 degrees. But when you measure that with respect to your x-axis, what is that angle? If you measure that with respect to your x-axis, you can see here clearly. If you are measuring angle with respect to your x-axis, the radius of the circle is B and the distance made between these 2 points is again K. So, if you bring only that triangle outside, so what I am doing is, I am bringing that triangle outside. So, I am taking like this, you can observe this thing. It is not a right angle triangle, be very careful. Okay. Now, this is your circle radius only, this is nothing but B and this is also B, you can observe here. This is total, sorry, this is only A, not B, just a moment. So, this will be your inner circle radius from origin, you can see here. So, if I take this triangle, let me show it clearly. So, this is the triangle which I am talking about. Okay. So, this is my inner circle radius A, shorter length. This is my outer circle radius, which is B, larger length, and the distance made between these 2 points, which is nothing but K. So, what are my 3 lines here? A, B and K. So, this is how you will get it. And the angle made between these 2 sides is obviously 45 degrees. Is it clear or not? The angle made between these 2 sides with respect to origin and this, the angle is definitely 45 degrees, because you are splitting this totally into equal part. So, it will be 45 degrees. So, what will be the representation here again? If you take K square, it will be equal to A square plus B square minus 2AB into cos 45 is again 1 by root 2. Now, my requirement is to get B in terms of K. So, how I can write K square? It is equal to, in place of A square, I can write K square by 2 plus B square minus 2 into A is K by root 2 into B into 1 by root 2. So, this value will be K square equal to K square by 2 plus B square minus root 2 into root 2, 2 and 2 will get cancelled, minus K into B. So, how you can write this expression? B square minus B into K minus K square by 2 equal to 0. So, this is the expression, quadratic expression, which you will get in terms of B. So, it will have 2 roots, you take the value which is positive. So, from here what is B? Minus B means it will be K plus or minus square root of B square, means it will be K square minus 4A into C minus B plus or minus B means it is minus K plus or minus square root of B square, means it will be K square minus 4A into C, minus of minus will become plus into 2K square by 2A, it will be 2. So, you take a value that is positive only. So, it will be K plus root 3 into K divided by 2. So, what is this value of B now? Is it clear or not? So, you can take that K common, 1 plus root 3 by 2. 1.366 K, that's all. So what is the energy on the 4 points located on this outer circle? Let us assume it is EY. So this will be equal to 4 points are there. So it will be 4 into the circle radius, which is equal to B square. So this will be 4 into that 1.366 K whole square. So it will be 7.464 K square, finish. So what is the total energy taken by the second plot, means 8 QAM, add these two values, Ex and this value Ey, 9.464 K square. So the energy taken by the second plot is 9.464 K square, that's all. So these are the energies taken by both the constellation plots. Now which is taking more and which is taking less, because K is same in both the cases. So obviously for the same value of D minimum or same noise performance, your QAM is giving a better energy when compared with PSK, because this is taking a value less than that value. So how much is the advantage you are having directly in dB? So power advantage or energy advantage of one plot when compared with another plot. Power advantage in dB is 10 log this E1 by E2 to the base 10, because he is asking in dB scale. Otherwise you can directly take the ratios itself. So if you take the ratios and take dB, into this value of 13.6588, so log of 1.433 dB into 10. So it will be 1.562 D. That's all. You can go up to 3 decimal places. So the power advantage which you are having on 8 QAM when compared with 8 PSK is 1.562 in dB scale. So this is how you have to do when these type of numericals are given. So generally what they will do is, they will give two plots, either both will have same D minimum and different energies like the one which you have seen, or sometimes what they can do is, they only will tell that energy taken by both the plots is same. So E1, E2 will be same, but D minimums will be different. So which plot will have a better performance in presence of noise when compared with the other plot. So that is how comparison of constellation plots numericals will be framed. So when it is circular plot, it is much easier for you to do the numerical. So that is the advantage that you will have. Okay, right. See this question. This is also a 2 marks bit. Consider noise in an electric circuit model using a Gaussian random variable with mean equal to 0 and variance equal to 10 power minus 8. So what is the data given to you? He is giving you noise modeled using a Gaussian random variable with these parameters. So let us assume my noise random variable is a Gaussian random variable n, and value of mean is 0 and variance is 10 power minus 8. Okay. So what is the density function of my noise now? The value of my f of n is 1 by square root of 2 pi sigma square is 10 power minus 8 into e power minus n square by 2 into 10 to the power of minus 8. So my noise can have any values between minus infinite to plus infinite. So this is about the noise. Okay. So because it is a Gaussian representation centered about a mean value of 0, so you can establish the noise probability density function using this figure. So x-axis is a noise random variable and this is the density function of my noise f of n. Okay, clear? Now what is he saying? Given that the value of noise is positive, means what is the condition he is applying? The value of noise is greater than 0. what is the probability that it exceeds 10 power minus 4? Means what is the question is asking? Probability of noise becoming greater than 10 power minus 4 given noise is greater than 0. Is it correct or not? Conditional event or not? It is already known that the noise is positive, means noise is greater than 0. That is an event that is already happened. What is the probability that noise can be greater than 10 power minus 4? So, how you can write this? This is like a probability of noise greater than 10 power minus 4. Probability of A given B, how you will write? Probability of A intersection B. That means probability of noise greater than 10 power minus 4 intersection noise greater than 0 divided by probability of noise greater than 0. Finish. Is it clear or not? That means this value we can establish as probability of noise greater than 10 power minus 4 given noise is greater than 0 is equal to noise value greater than 10 power minus 4 intersection noise greater than 0 means what? This is greater than 0, this is greater than 10 power minus 4. What is the intersection? Obviously it should be n greater than 10 power minus 4 only divided by what is the probability of noise greater than 0? Is it 1 by 2 or not? Because the density function is symmetric about the origin. Total area of the density function is 1. So, if you take a integral f of n dn, this value is 1. Now, if you want probability of noise greater than 0, you have to integrate the density function from 0 to infinite. So, minus infinite to 0 integral or 0 to infinite integral is half. So, that is the reason directly you can write half equal to 2 into probability of noise greater than 10 power minus 4. Finish. So, how you can write this? 2 into, I can write this as 1 minus probability of noise less than or equal to 10 power minus 4. So, this is nothing but 2 into 1 minus value of the distribution function of noise at 10 power minus 4. Correct or not? So, this is equal to 2 into 1 minus, what is the distribution function of the Gaussian random variable? 1 minus the q of x minus mu by sigma. So, I am writing that 1 minus q of n is a 10 power minus 4, mean is 0 divided by sigma is 10 power minus 4. Variance is 10 power minus 8 means sigma should be 10 power minus 4. That's all. So, how much you will get? This becomes 1 minus q of 1. 1 and minus 1 will get cancelled. Minus of minus will become a plus. So, you will get a value equal to 2 into q of 1. That's all. Over. So, your answer should be 2 into q of 1. So, this concept is based on Gaussian random variable and using conditional event. So, once you write this, then remaining part is very, very simple. So, just to draw that density function curve for your reference. So, these are based on complete random variable concept. So, these type of questions are very, very important for your exams. Let us see the last bit. This is also a 2 marks bit. I have taken it from wideband FM generation. So, see the question given. Consider generation of wideband FM signal shown in the figure. So, basically what he is doing, he is considering a message signal m of t. What are the parameters? M of t has a bandwidth of 15 kHz. Message signal bandwidth means its maximum frequency. It is given as 15K. Okay. And what is he saying? The carrier frequency of the wideband FM signal generated should be 104 megahertz. Means the wideband FM signal carrier frequency, final carrier frequency, it should be 104 megahertz. Okay. With a frequency deviation, maximum value of frequency deviation of how much? 75 kilohertz. This is the parameter he is giving you. Okay. Considering only up converters. Up converters means what? When you multiply the two signals, you will get f1 plus f2 and f1 minus f2. Up converter means you will take only f1 plus f2. So, no need to specify a band pass filter there. That is the meaning. Generally, whenever you multiply f1 and f2 frequencies, you will get the sum and difference of the frequencies. Down converter means f1 minus f2. Up converter means f1 plus f2. That is what he is saying. Considering only up converters, the possible values of integers n1 and n2 are respectively dash. So, he is asking what is the frequency multiplier n1 value and what is the frequency multiplier n2 value. Finish. Okay. Now, see what is done here. He is taking message signal m of t and operating here with a carrier frequency of 100 kilohertz. okay, and generating a value of beta which is equal to 0.1 at this stage. Is it clear or not? That means what is the meaning here? What is your beta? Beta is 0.1 is delta f max, initial value of delta f max by f max. So what is this delta f max dash? It should be equal to this 0.1 multiplied by f max is 15 kilohertz. Correct or not? So this value will be equal to 1.5 K. That is the first part. Now the delta f max you are having at this stage, this is delta f max. For identification I am writing dash equal to 1.5 K. Now once it goes through a multiplier of N1, what should be the final value of delta f max that should come here? It should be equal to 75 K. That means what is your frequency multiplier? This delta f max should be equal to this N1 multiplied by delta f dash max. That means 75 kilohertz is equal to N1 into 1.5 kilohertz. So therefore, what is the value of N1? It becomes 75 divided by 1.5. So you can write this as 50. Is it clear? So N1 is equal to 50. If you see your options, you can easily go with option C, because out of the 4 options, N1 is given as 50 only for option C. Let us try to find N2 also. Now what is N2? Your N2 is involved with the carrier frequency. Correct or not? So what is happening here? This is having a frequency F0 which is 100 kilohertz getting multiplied by N2. So basically what is happening here, when you take only the up converter, the final frequency of the carrier should be 104 megahertz. Is it correct or not? So what is happening here? N2 into F2, correct or not? N2 into F0, I will keep F0 here. And what is happening here? When you take this N1, it is getting multiplied by N1. The same carrier frequency is coming here and getting multiplied with N1. That means what it is happening here, plus when you take N1 multiplied by F0, correct or not? Did you get my point or not? Whatever N2 is your frequency multiplier is getting multiplied by here, and the same F0 which is generated at this stage, here at this stage it is still 100 kilohertz only, it is getting multiplied by N1. So when you come here, it will be sum of these two frequencies, because you are dealing only with the up converter. Now this final result, whatever you are getting, should be equal to how much? Should be equal to the final carrier frequency is 104 megahertz. Take it. That means N1 plus N2 into what is the value of F0? 100 kilohertz means 10 power 5 equal to 104 into 10 power 6. So N1 is 50 plus N2 equal to 1040. So what is N2? It will become 990. That's all. So your choice will be option C. So this is a Armstrong method, indirect way of generation of wideband FM signal from narrowband FM signal. Okay. So this is how simple numericals can be framed. So I have taken 2 marks questions mostly from digital communication, giving more important to that area, and also random variables and random process. So these are some questions which almost, I don't say that the same questions will come, it will be similar lines, same model of questions can come. So I wish you all the best. Try to do without any mistakes.
Yeah, in this problem, a 4 gigabyte byte addressable memory is given. And if he is asking if each memory location contains 4 bytes, then what is the number of address lines and what are the number of data lines? We know that the number of bits stored in each memory location is called as one word. So if 4 bytes are stored in each memory location, then it's going to be one word equal to 32 bits. So in this problem, he is asking you to convert a byte addressable memory into a word addressable memory. So we know the procedure how to compute. Number of bytes in each memory location is called one word, that is equal to 4 bytes. Let us express this in terms of bits. The size of word addressable memory will become now 2 power x multiplied by 32, where x is number of address lines. So equate 1 and 2, then we are going to compute the value of x. So 2 power x equal to 2 power 30, that means x equal to 30. So it contains 30 address lines and 32 data lines. So the correct answer is B. Address bus 30 bits and data bus is 32 bits.
Hi, myself P. Venkatrao. Now, pre-gate maths questions I'll discuss for both electronics and communication engineering and electrical engineering. Question number 1 from calculus. Just observe this, the area of the region bounded by the parabola y minus 2 whole square equal to x minus 1, the tangent to the parabola at the point 2 comma 3 and x-axis. Means we have to sketch the area occupying or bounded by y minus 2 whole square equal to x minus 1, and we have to draw a tangent to the parabola at the point 2 comma 3 that will touch x-axis at some point, and sketch the area bounded by x-axis and the parabola and the straight line. So first of all, rough diagram, let me draw rough diagram. Do you know this is y square equal to x parabola? This is y square equal to x parabola. If x is replaced by x minus 1, same parabola shifted 1 unit right. So observe this, y square equal to x minus 1. Y square equal to x minus 1 means same y square parabola is shifted just 1 unit right from its original position. This is y square equal to x minus 1 parabola. Because if x is replaced by x minus 1, the original parabola shifted 1 unit right from its original position. Similarly, if y is replaced by y minus 2, then its original parabola will be shifted up 2 units from its original position. If y replaced by y minus 2, if y replaced by y minus 2, the same parabola will be shifted up 2 units from its original position. This is the original position. Same parabola shifted up 2 units from its original position. Same parabola shifted up 2 units. So this is y minus 2 whole square equal to x minus 1. This is y minus 2 whole square equal to x minus 1. So first of all, let me draw a tangent. Before this, first of all, what is the given parabola? Given parabola is y minus 2 whole square equal to x minus 1. First of all, you should know equation of the tangent. So to get equation of the tangent, first you have to find the slope. To get slope, differentiate both sides of this equation with respect to x. Y minus 2 whole square derivative 2 into y minus 2, and again y derivative with respect to x is dy by dx equal to x derivative with respect to x is 1. So this is, from this dy by dx is, from this dy by dx equal to 1 by 2 into y minus 2, because you have to draw a tangent to the parabola at the point 2 comma 3. Therefore, you need slope of the tangent. We require slope of the tangent at the point 2 comma 3. So slope of the tangent denoted by m, also denoted by dy by dx. So slope of the tangent required at the point 2 comma 3. So substitute x equal to 2, y equal to 3 there. Then it becomes 1 by 2 into y value 3, 3 minus 2, 1. So slope of the tangent is 1 by 2. What is the equation of the tangent? Because you have to draw the tangent to the parabola at the point 2 comma 3. Rough diagram I am saying, rough diagram, you want equation of the tangent to the parabola at the point 2 comma 3. At the point 2 comma 3. So equation of this tangent we have to find. This tangent is drawn to the parabola at the point 2 comma 3. So therefore equation of the tangent formula, y minus, here y coordinate, this is x1, this is y1, y minus y1, y1 value 3, y minus y1 equal to m, m means slope, that is 1 by 2 into x minus x1, x coordinate is 2, x coordinate is 2. So from this find x value or y value, so multiply both sides by 2, then it becomes 2y minus 6 equal to x minus 2. So from this find x value. So from this minus 2 will go this side. So x equal to 2y minus 6 plus 2. Minus 6 plus 2, that is minus 4. This is equation of the tangent to the parabola. So first of all, now we have to draw the diagram. Rough diagram only. and draw a tangent to the parabola. Draw a tangent to the parabola at the point 2, 3. Tangent has been drawn to the parabola at the point 2, 3. To know this parabola where it touches x-axis, to know this tangent, this is equation of the tangent. To know where it touches x-axis, substitute y equal to 0. If I take y equal to 0, x value minus 4. So that means x value minus 4 on x-axis, y coordinate 0. I mean this parabola touches x-axis at minus 4, this tangent touches x-axis at minus 4, 0, that's fine. And to know this is the parabola, to know this parabola where it touches x-axis, to know your parabola where it touches x-axis, substitute y equal to 0. If you take y equal to 0, then 0 minus 2 whole square, 4 equal to x minus 1. So from that x equal to 5. So this parabola touches x-axis at 5. Now sketch the area. Sketch the area occupying by x-axis, tangent and parabola. This is the area occupying by x-axis and everything. This. Now what is the area formula? What is this parabola equation? Parabola equation, y minus 2 whole square equal to x minus 1. So from this, what is x value? Y minus 2 whole square plus 1. So that is x value. So what is the area formula? Now let us write. Area equal to integral a to b x dy. That is integral upper curve x value minus, right curve x value minus left curve x value. What is right side curve? Total shaded region, this is right side curve. Right side curve x value, y minus 2 whole square plus 1. Right side curve x value, y minus 2 whole square plus 1 minus left side curve x value. Left side curve means this is left side curve. What is this left side curve? Straight line. Tangent. Tangent is x equal to 2y, x equal to 2y minus 4. Area formula, right side curve x value, total shaded region right curve x value minus left curve x value. Minus of left curve x value, that is 2y minus 4 into dy. So we are integrating with respect to y, so we just need y limits. So here starting point y limit 0, ending point y limit 3. So y limits 0 to 3. So then we have to simplify this. Then you will get answer 3, 0 to 3, y minus 2 whole square, that is y square minus 4y plus 2 square, 4 plus 1, 5, minus into 2y minus into minus 4 plus 4 into dy. So from this integral 0 to 3, this is y square minus 4y minus 2y minus 6y plus y plus 5 plus 4, 9 into dy. This is equal to integral 0 to 3 y minus 3 whole square. Y minus 3 whole square. Dy I can write dy minus 3. Dy I can write dy minus 3 because d of 3, differential of 3, 0. Differential of 3, 0. Dy equal to dy minus k because differential of k 0. D into y dy, okay, derivative or differential of 3 will be 0. So I can write like this. This is y minus 3 whole square. So therefore treat it as t, integral t square dt, integral t square dt, that is t cube by 3. T cube by 3, that is y minus 3 whole cube divided by 3 between the limits 0 to 3. So replace, otherwise we can do like this. Otherwise we can simplify like this also. Instead of doing, then we can directly simplify. So integral y square dy, that is y cube by 3 minus 6y square by 2. 6y square by 2, that is 3y square plus 9y. Between the limits is 0 to 3. So replace y by upper limit 3, 3 cube 27, 27 by 3 9 minus 3 into 3 square 27 plus 9 into 3 27. So minus 27 plus 27 cancel, answer 9. Directly we can write. What is the purpose of directly writing y minus 3 whole square? We can directly getting the answer. It is 9. Now you observe which of the following statements it is MSQ, which of the following statement is true, or which of the following statements are true. It's a property. You should remember properties of rank of a matrix. As we all know, rank of A plus B less than or equal to rank A plus rank B, rank of A minus B greater than or equal to rank A minus rank B. So accordingly, options B and D are true. Next. You observe this question carefully. Two boxes contains 10 chips each. So first box has 10 chips numbered from 1 to 10. Second box will also have 10 chips numbered from 1 to 10. And one chip is drawn at random from each box. The probability that sum of the numbers drawn on the chips is greater than 4. So instead of doing sum of the numbers drawn on the chips is greater than 4, it is easy to calculate sum of the numbers on the chips drawn should be less than or equal to 4. So that's why let us assume A equal to sum is less than or equal to 4, because sum of the numbers on the drawn chips should be less than or equal to 4, I assume. So A complement means exact opposite meaning of less than 4. Exact opposite meaning of less than 4 is sum greater than 4. We were asked to find sum of the numbers on the drawn chips is greater than 4. Sum greater than 4. Probability of sum greater than 4 means we have to find P of A complement. P of A complement value 1 minus P of A. So before that, first look favor. So first you observe favorable cases or total cases. Total cases how many? Two boxes contains 10 chips each. So first box has, from the first box one chip is drawn. So 10C1, from the second box one chip is drawn, 10C1, 10C1 into 10C1, that is 10 into 10, 100. So favorable cases for A. Favorable cases for A, 6 cases, as you can see now. So favorable cases for A means favorable cases for sum of the dots on sum of the numbers on two chips is less than or equal to 4. So these are 1, 1, 1, 2, 1, 3. First chip, first box 1, second box chip 1. So sum is less than or equal to 4. Sum is less than or equal to 4. Next, 2, 1, 2, 2, 3, 1. These are the cases where sum is less than or equal to 4. Total how many cases? 6 cases. So probability of A equal to favorable cases 6, total cases 100. This is probability of A. Then actually we have to find P of A complement, no? So that is 1 minus P of A, that is 1 minus 6 by 100, that is 94 by 100, that is 0.94. That is 0.94, right? So it is a fill in the blank question. So answer 0.94. Next, you observe this. Consider the following system of linear equations. Consider the following system of linear equations. If the system has at least one solution, then what is the value of lambda? Do you know if the system of equations are consistent? Consistent means at least one solution. At least one solution meant for consistent. So for what value of lambda system of equations is consistent? Means for what value of lambda rank of AB equal to rank of A, that is to be shown, that is to be proved. So for that directly let us write augmented matrix. Augmented matrix AB equal to first equation XYZ coefficients first row 3 minus 1 4. 3 minus 1 4. Second equation XYZ coefficient second row 1 2 minus 3. Third equation XYZ coefficients third row 6 5 lambda. First equation right side 3, second equation right side minus 2, third equation right side minus 3. 3 minus 2 minus 3. Minus 2 minus 3. Reduce this augmented matrix AB to echelon form. So for that we have to select the first row first element. Using the selected element, all elements below it must be made zeros with the help of row operations. Make these two numbers zeros using this number, that I can write 3R2 minus R1 and R3 minus 2R1. R3 minus 2R1. So the augmented matrix AB equal to first row no change 3 minus 1 4 3. 3 times of second row minus first row 3 into 1 3, 3 minus 3 0, 3 into 2 6, 6 plus 1 7, 3 into minus 3 minus 9, minus 4 minus 13, next minus 6 minus 3 minus 9, third row minus 2 times of first row, that is 6 minus 6 is 0, 5 minus 5 plus 2 7, lambda minus 8, lambda minus 8 minus 3 minus 6 minus 9. So once we make all elements below the first row first element as zeros, then go to the second row second element and select the second row second element if it is some non-zero number. Once it is selected, using the selected number only below elements are to be made zeros. Means make this number 0 using this number with the help of row operations, that is third row minus second row. Your row operation would be third row minus second row. So rewrite the augmented matrix AB now. So AB equal to 3 minus 1 4 3. 0 7 minus 13, 0 7 minus 13, I think minus 9. Yeah, fine. So third row minus second row 0 minus 0, 7 minus 7, 0 0, lambda minus 8 minus of minus 13, lambda minus 8 plus 13, 13 minus plus 13 minus 8 5. So lambda plus 5, 13 minus 8, next minus 9 minus 9, minus 9 minus of minus 9 plus 9 0. So this is the augmented matrix AB and it was reduced to echelon form. As you all know, from here to here matrix A, from here to here matrix B. This is matrix B. So for what values of lambda rank of A equal to rank of AB such that the system of equations to be consistent. If I take lambda equal to minus 5 here, minus 5 plus 5 0. So then this row will become 0 0 0. Then matrix A will contain only two non-zero rows. So rank of A 2. If I take lambda equal to minus 5 here, it is 0. Then matrix AB also contains two non-zero rows. So matrix A rank 2 and matrix AB rank 2 for lambda equal to minus 5. So rank of A equal to rank of AB for lambda equal to minus 5. For lambda equal to minus 5, Rank is denoted by this symbol which we read it as rho. Rho of A means rank of A. Rank of A equal to rank of AB. Therefore, system consistent. System consistent means system will have at least one solution. System has at least one solution for lambda equal to -5. Next, observe this. You are asked to find, look at this question. We were asked to find sum of the residues of the function f of z equal to z cube by z minus 2 into z minus 3. So, first denominator is to be equated to 0. Let me write the given function first. Given f of z equal to z square by z minus 2 into z minus 3. Denominator is equated to 0. Whatever the z values we get, which are called singular points. If I take z equal to 2 in the numerator, 2 square, so 2 cube. If I take z in the numerator, that's fine. And observe, first of all, write the given function f of z equal to z cube by z minus 2 into z minus 3. Denominator is equated to 0, whatever the z values we get, which are called singular points. If I take z equal to 2 in the numerator, numerator becomes 2 cube, 8. That means a numerator not equal to 0 at z equal to 2. Therefore, z equal to 2 is a simple pole. In the similar manner, z equal to 3 is also a simple pole. So, these are the simple poles. Simple poles means pole of order 1. So, calculate the residue at each simple pole. So, I am calculating residue of f of z. I am calculating residue of f of z at the simple pole z equal to 2. Z equal to 2. This is equal to z equal to 2 simple pole obtained from this part of the function. Therefore, to get the residue at the simple pole z equal to 2, simply delete this part and put z equal to 2 in the remaining part. Whatever you get, that would be the residue at that simple pole. So, delete this part and substitute z equal to 2 in the remaining part. Then it becomes 2 cube by 2 minus 3, 2 cube 8, 8 by minus 1, that is minus 8. Similarly, let me calculate residue of f of z at the pole z equal to 3. To get the residue at the simple pole z equal to 3, z equal to 3 simple pole is obtained from this part of the function. So, to get residue at the simple pole, simply delete this part and put z equal to 3 in the remaining part. Whatever you get, that would be the residue at z equal to 3. Simply substitute z equal to 3 in the remaining part, then it becomes 3 by 3 minus 2. So, that is 27. So, we were asked to find sum of the residues. Sum of the residues is minus 8 plus 27, that would be 19. Sum of the residues is 19. It's a fill in the blank question. It's not fill in the blank question. MCQ option A, 19 is correct. Next, you observe this. Read out the question carefully. 3 persons ABC in order roll a fair die. The first one to roll an even number wins the game and the game is terminated after that. Assume that person A rolls the die first, the probability of A winning the game is. So, the question, it is a standard question. This model was given several times in the GATE exam. 3 people ABC are throwing a die in the order ABC. First A will throw, next B will throw, next C will throw. Again A will throw, B will throw, C will throw. ABC, ABC, ABC. So, 3 people ABC are throwing a die in the sequential order A first, B next, C next. I mean ABC, 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 so on, until one of them gets an even number on the die first. Whoever whoever first gets even number on the die first, that fellow can win the game. Assume that player A starts the game. Probability of player A winning the game is, it's a standard question, everyone should remember, and we have a derivation. It's probability of A winning the game. It is a standard question and answer is also standard. So that is P of A by 1 minus P of A complement whole cube. So 3 people know, that's why it is whole cube. Suppose 2 people, it is whole square. 4 people, it is whole power 4. Now first let me write probability of A winning the game, probability of A winning the game, probability of B winning the game, probability of C winning the game, same. Because whoever gets even number on the die first, that fellow can win the game. Probability of A winning the game means probability of A getting number 6 on the die. Probability of A getting number 6 on the die is 3 by 6, that is 1 by 2. Similarly, probability of B winning the game is probability of B getting even number on the die, that is 3 by 6, 1 by 2. So similarly, P of A complement, P of B complement, P of C complement, this is also 1 minus 1 by 2. Now put this data there. Probability of A wins the game equal to, what is the formula? P of A, numerator. So P of A means 1 by 2 by 1 minus denominator P of A cube. P of A cube 1 minus A cube means 1 by 2, 1 by 2 whole cube, that is 1 by 8. So this is equal to 1 by 2, 1 minus 1 by 8, that is 7 by 8. So that is equal to 1 by 2 into 8 by 7, that is 4 by 7. So probability of A winning the game is 4 by 7. So probability of A winning the game is 4 by 7. Therefore option D is the right answer, 4 by 7. Now you look at the differential equation. If the differential equation, so you are asked to find complementary function and particular integral. So first of all, as you all people know, this is Cauchy-Euler. Cauchy-Euler is x square into d square y by dx square is replaced by d into d minus 1 into y, or theta into theta minus 1 into y, minus plus into minus minus x into dy by dx is capital D into y. X into dy by dx is capital D into y plus 5y equal to right side x. Right side x, as you all know, in this model, assumptions would be log x equal to t, so that x equal to e to the power of t. That is the assumption, as we all know. So therefore right side x is there. So x means e to the power of t. So y common factor d into d, d into d square, d into minus 1 minus d into y minus dy, minus 3 dy, minus 4 dy, y common, plus 5y, y common. So this equal to e to the power of t. So write the auxiliary equation in order to find the complementary function. Auxiliary equation d square minus 4d plus 5 equal to 0. Find the roots. This is a d equal to 4 plus minus square root of b square minus 4 whole square 16 minus 4 ac 20 divided by 2. So that is root minus 4. Root minus 4, I can write it as 4 plus or minus root minus 4 by 2. D equal to root minus 4 can be written as square root of 4i square. I square or j square? By 2. I square value minus 1 into 4 minus 4. So this is equal to 4 plus minus 2i divided by 2. Next to 4 by 2, that is 2. Plus minus 2i by 2, that is I. 2 plus or minus I. Roots are conjugate, complex conjugate, a plus or minus ib. A plus minus ib, then what would be the complementary function? Complementary function would be e power ax, a plus minus ib, e power ax 2x c1 cos b e power ax at, because capital D means d by dt in this model. C1 cos bx, b value 1, plus C2 sin bx, b value 1. X means t, because capital D is d by dt. So complementary function, this is x square, x equal to e power t, so that x square equal to e power t whole square, that is e power t into e power t, e power t into e power t, that is e power 2t. C1 cos, our assumption for t would be log x, plus C2 sin t means log x. Complementary function completed, x square into C1 cos log x plus C2 sin log x. Option A correct. The complementary function is x square into C1 cos log x plus C2 sin log x. So option A, as of now, option A correct. Now let us calculate particular integral as well. So pi equal to 1 by dependent variable y coefficient, that is d square minus 4d plus 5. D square minus 4d plus 5 into right side of the given differential equation t. So to solve type 1 particular integral, d should be replaced by 1 e power ax, a value 1, x means t. Replace d by 1, then it becomes 1 by 1 square minus 4 into 1 plus 5 into e power t. 1 plus 5, 6, 6 minus 4, 2. So 1 by 2 into e to the power of t. But what is our assumption for e power t? E power t is x by 2. So particular integral x by 2. So option B also correct. The particular integral is x by 2. So option B also correct. Option C wrong. The particular integral is 2x wrong. And option D is correct. The general solution is x square into C1 cos log x plus C2 sin log x. That is CF part, I mean complementary function part, and particular integral is x by 2. That's it. Therefore option D is also the right answer then. Next question and the last question then. So don't get confused, it's a printing mistake. X limits is 0 to 1, not x, see here, not x limits is 0 to 12. So little bit gap should be there. So x limits is 0 to 1, y limits x squared to 2 minus x, xy dy dx. Now let us solve this. The given question, let it be I. For my convenience, I would like to assume it as capital I means integral, where x limits is 0 to 1, y limits x squared to 2 minus x, xy dy dx. Order of integration first y and then x. So when you are integrating with respect to y, at that time y is only the variable, other variable x is kept constant. So x a constant, integral y dy, that is y square by 2 between the limits x squared to 2 minus x into dx. This two I will write it out. Therefore it is equal to integral 0 to 1 x by 2 into, replace y by upper limit 2 minus x whole square, minus replace y by lower limit x square whole square. Now into dx is there. I equal to integral 0 to 1 2 minus x whole square, that is 2 minus x whole square, that is 4 plus x square minus 4x, 4 plus x square minus 4x minus x square whole square, that is x to the power of 4 minus x square whole square x power 4, 4 plus x square minus 4x, that's fine. Now take this x inside the bracket, 4x by 2 plus x by 2 into x square, that is x cube by 2, x into 4x, 4x square by 2, 4x square by 2, that is 2x square, minus x into x power 4, x power 5 by 2 into dx. X to the 4x integration, so 4x by 2, no, this is 2x. 4x by 2, that is 2x, x cube by 3 minus 2x square minus x power 5 by 2, that's fine. Integral 2x dx, x square, x cube integration x power 4 by 4, 4 3s are 12, minus 2x cube by 3 minus x power 6 by 6, 6 into 2, 12. Between the limits is 0 to 1, replace x by upper limit 1, then it is 1 plus 1 by 12 minus 2 by 3 minus 1 by 12. So fortunately, plus 1 by 12 minus 1 by 12 cancel each other, 1 minus 2 by 3. One minute. Integral 0 to 1, y limits x square to 2 minus x. So x into integral y square by 2, that is 2 minus x whole square minus x square whole square. So x by 2 into 2 minus x whole square, that is a 4 plus x square minus 4x square minus x power 4. So 4 by 4x by 2, that is 2x, x cube by 3, 2x square minus x power 5 by 2. 2x square by 2, 2x square by 2x square, x power 4 by 4, 12 minus 2x cube by 3 minus x power 6 by 12. Up to here is fine. Now this is equal to 1 plus 1 by 12 minus 2 by 3 minus 1 by 12. This cancel, 1 by 3. Let's continue this and observe. So I equal to 1 by 2 into integral 0 to 1. Take this x, first of all, x into, what is this bracket? 2 minus x whole square. 2 minus x whole square is 4 plus x square minus 2x, 4 plus x square minus 4x, 4 plus x square minus 4x minus x power 4 into dx. So 1 by 2 into integral 0 to 1 x into, so take this x inside, then it is a 4x plus x cube minus 4x square minus x into x power 4, x power 5 dx. So this is equal to 1 by 2 into integral 4x dx, 4x square by 2, that is 2x square, x cube integration x power 4 by 4 minus 4 x square integration x cube by 3 minus x power 5 integration x power 6 by 6 between the limits 0 to 1. So replace x by upper limit 1, 2 into 1, 2 plus 1 by 4 minus 4 by 3 minus 1 by 6. So simplify that. This is equal to 2 into 1 by 2, that is 1, plus 1 by 2 into 1 by 4, 1 by 8 minus 2 by 3 minus 1 by 12. This is the integral value, and observe this is equal to 1 minus 2 by 3, that is 1 by 3 plus LCM of 8 and 12, that is 24, 8 3s, 12 2s, So this is equal to 1 by 3 plus 1 by 24, and LCM of 3 and 24, 1 by 3 can be written as 8 by 24 plus 1 by 24. I just wrote 1 by 3 as multiply and divide by 8. 8 ones 8 3s. 8 by 24 plus 1 by 24, that is 9 by 24. That is 3 3s, 3 8s. 3 by 8, I think 0.375. 3 by 8 answer, I think 0.375. That's it. That is the answer.
Hello friends, let's have a look at the solutions of general aptitude. I'm dealing with numerical ability and logical reasoning part. In that one, first one that is given is find the remainder when 2 power 101 is divided by 5. There are different methods of attacking this problem. I'll deal with one simple technique here, that is concept of negative remainder. Or you try to adjust the power of 2 in such a way that when you are dividing that with 5, you are going to get a remainder of either plus 1 or minus 1. You try to adjust in that manner. Like if you check it that way, so this can be written as 2 to the power of, when you know, like 2 when divided by 5, remainder will be 2. 2 square when divided by 5, remainder will be 4. Or I can also call it as minus 1. Because when you divide 4 with 5, remainder can be either 4 or minus 1. Keep that in mind. Now, if you can understand this one, so solving this problem becomes very easy. Now, going ahead with this 2 power 101 divided by 5 is what we are looking for. So, you simply write it as remainder of 2 power 101 can be written as 2 square whole to the power of 50, that is 2 power 100 into 2 power 1. This is what I can say. So, remainder of when you are dividing that with 5. So, it is as simple as when you are dividing this 2 square with 5, remainder is nothing but minus 1, you know. When you divide this 2 square with 5, remainder will be minus 1. When you are dividing the number which is to the power of 50 for that, the remainder will be minus 1 to the power of 50. Into, when you divide 2 power 1 with 5, remainder will be 2. So, effectively remainder will be minus 1 to the power of 50 will give you 1 into 2. So, that will give you a remainder of how much? 2. I repeat, whenever you are dividing a particular number, you try to adjust the number in such a way that it is either 1 more or 1 less than power of 5 or multiple of 5, I can say. So, I am just writing this 2 power 1 as 2 power 101 as 2 power 1 is 2, remainder will be 2 when I am dividing it with 5. 2 square when divided by 5, remainder will be either plus 4 or minus 1. This is called as concept of negative remainder. Now, you try to write it in such a way that this is to the power of 2 square only, such that the remainder will give you minus 1. When you divide this 2 square with 5, remainder will be minus 1. Minus 1 to the power of 50 will give you 1 only into 2. So, 1 into 2 will give you 2. Say suppose you are having an odd power over here, you will get minus 1 here. If your answer you are getting here is negative, you add it to the divisor. So, that is 5. If you are getting minus 2 here, you add minus 2 with 5, that will give you 3 as the remainder. If you are getting a positive remainder, so that will be your answer. So, hence your answer has to be what? 2 here. It can also be done by a method called as concept of cyclicity also. By cyclicity method also this can be done, right? So, coming to that method of cyclicity over here. So, what is that method of cyclicity? Let's understand that also. So, coming to second method. When you are dividing 2 power 1 with 5, remainder will be 2. 2 square when divided by 5, remainder will be 4. 2 cube when you divide it with 5, remainder will be 3. 2 power 4, 16 when divided by 5, remainder will be 1. So, 2 power 5, 32 when divided by 5, remainder will be 2. That means this remainder is repeating after 4 powers. That means whenever you are having a particular power for 2, after every 4 powers, this remainder of 2 will keep on repeating. That means if you go ahead with this 2 power 101 can be written as, you just simply check this one. 2 power 101 is equal to what? So, remainder of 2 power 101 will be equal to, so you are getting a cyclicity of 4 now. You are getting a cyclicity of 4 means after 4 cycles the remainder is getting repeated. You simply do one thing. Divide this 101 with the cyclicity. Cyclicity means after how many powers it is repeating. take the remainder here. 101 by 4 is equal to what? Remainder you take. 425 is 100, remainder will be 1. It is as good as 2 power 1 remainder. 2 power 101 remainder will be same as 2 power 1 remainder. What is the remainder when you are dividing 2 power 1 with 5? That is 2. Hence, I can say that the remainder will be how much? 2 simply. So, I repeat, remainder of 2 power 101 will be equal to remainder of 2 power 1 when divided by 5. Hence, it has to be what? 2. As simple as that. Coming to the next one. This is a problem related to number series. Right? Going ahead with 10, 30, 68, 130, 222. The next term in the given series is what? So, 10 can be written as, if you are having an idea about, as I said in the classes, as we generally suggest when discussing number series, try to know the squares and cubes of the numbers up to 25. That will help you a lot in cracking the problems related to number series. So, here 10 is nothing but, I can simply write it as 2 cube plus 2 is 10, 3 cube plus 3 is 30, 4 cube plus 4 is 68, 5 cube plus 5 is 130, 6 cube plus 6 is 222. Hence, it has to be, next one is what? 7 cube plus 7. We know that 7 cube is 343, 343 plus 7, 343 plus 7 should give you how much? 350. Hence, it has to be option D here. Right? As simple as that. So, please be aware of that squares, cubes. So, if you are aware of that squares and cubes, it is easy for you to identify that is related to which particular number. If you are not learning that squares and cubes, you will always have a doubt. See, the fundamental mistake that many people do here is, they will try to look at the difference or multiplication always. And so, not always the series may be having difference or multiplication property, right? Keep that in mind. Let's go ahead with the next one. These two are for given for 1 mark each. Next one. There is a window which is in the shape of a semicircle fixed on a square. There is a semicircle which is fixed on a particular square. The side of the square shape is 14 meters. So, the side of the square shape is given as 14 meters. Then find the area of the window. So, area of the window is nothing but area of the square plus area of the semicircle is what I can say. Right? So, if you observe this entire thing for the circle will become the diameter of the circle. If the diameter of the circle is 14, radius will be 7. So, radius of that circle will be 7. So, area of the window is nothing but area of the semicircle plus area of the square is what I can say. Area of the semicircle plus area of the square. Now, going ahead with area of a semicircle is nothing but half of pi r square. Half of pi r square is the formula for the area of a semicircle, plus area of the square is nothing but side square. So, half of pi r square. Now, going ahead with half into pi is nothing but 22 by 7 into r square is nothing but, don't take 7 square 49, you write it as 7 into 7 plus side is 14 square. That is this is the area of the square. Now, going ahead with now. So, here 7 gets cancelled, here 2 11 times, 11 7s are 77 plus 14 square is 196. 196 plus 77 adds up to 273. Hence, it has to be option A. So, here the area is a combination of the area of the square plus area of the semicircle. That is the only point that you have to be aware of, right. Let us have a look at the next one. This is a problem related to data interpretation part over here, which is a combination of one pie chart, the other one table. So, it is a combination of pie chart and a table put together. Now, going ahead with the following pie chart shows the number of employees falling under different categories based on their work, and a table shows ratio of male to female in particular category. So, pie chart is given. So, they are talking about different types of people who are lazy, hardworking, skilled and efficient, and in every category the ratio of the male and female is also mentioned over here. Now, number of employees in the company is given as 22,500. This entire number of employees is corresponding to 22,500, which is nothing but 100% is 22,500. Now going ahead with, then the number of skilled male employees exceeds the number of lazy male employees by how much? Number of skilled male employees. So skilled male employees, first of all, how many people are there in skilled? 20% are there in skilled. Out of the 20% of the total, male and female are in the ratio 2:3. Hence I can say that number of male employees who are skilled is nothing but 2 parts out of 5 parts. So this total is adding up to 5 parts. So divide that into 5 parts. So 2 out of 5 I can say, 2 out of 5 of 20% of 22,500. 22,500. That represents the number of skilled male employees. Number of skilled male employees is corresponding to this much. So 20% of this is nothing but 10% is 2,250, 20% is 4,500. That is as simple as 2/5 of 4,500, which is nothing but 1,800. That is the number of skilled male employees. Number of skilled male employees. Coming to the number of lazy male employees. Total lazy employees are how much? 30% of the total. 30% of the total are lazy. Out of that lazy people, how many are male? So ratio of male and female is 1:4. That means divide this into 5 parts. Out of that, 1 part is male. Hence I can say that 1 out of 5 out of 30% of 22,500. 30% of 22,500. Right? Now going ahead with, so here if you go ahead with 10% of this is nothing but 2,250. 30% is nothing but 3 times of that, which is 6,750. So 1/5 of 6,750. So if you go ahead by cancelling this one, this will give you how much, dear? If you cancel it with this one, that will give you 1,350. So this is 1,350, this is 1,800. The question is, what is the difference between those two values? What is the difference over here? 1,800 here, 1,350 here. The difference is coming out to be 450. Hence it has to be option A. Right? Next. This is a problem based on spatial aptitude, where they are talking about the mirror image. Right, going ahead with, which of the following option is right image of prayer with respect to y-axis? With respect to y-axis means here is the mirror. Mirror is located over here. Just remember one thing, whenever you are looking at the mirror, left will become right, right will become left, left will become right, right will become left. Whenever you are looking into the water, top will become bottom, bottom will become top. The difference, if you can understand handling this, is very simple. Now if this is prayer, if this is looking at the mirror over here, left will become right, right will become left. So you can say that P is here, so that P looks like this in the mirror, P looks like that in the mirror. So if you observe the options over there, so it starts like this, P, so ending one will be P, so after that R will come, so R will look like this. So look at the option which is having that way. There is only one option which is satisfying that. Hence it has to be PR. So whenever you are solving, don't try to solve entire problem. Look at the options. So if you look at the options over here, this is very simple. After P, after P itself you can decide. So last letter should be P, and that should be left should be becoming right, and right should be becoming left. Right. Next, this is related to verbal reasoning. This is also related to verbal reasoning. Right. All these are verbal. So those are the questions that are given from reasoning and aptitude part. Thank you and wish you all the best.
Hi guys, let's look at the solutions. Read this. It will take time for the higher rates to feed dash to investors. It's a phrasal verb. He has given a verb asking you to supply the tail particle we called. Now look at the meanings. If I say feed through, convince, feed up, giving large amount of food, feed off. Feed off is like drawing inspiration. or drawing strength from, or drawing energy from other source, and feed on, like consume, eat for survival, living. Now with this, I think you can make out, it will take time for the higher rates to feed through. That's the right word there. Choose the option to fill in the blank. Grammatical problem. Teacher asked two students the answer of a question, okay? But, look at the clue here, but dash of them no, dash of them no. So I am looking for the negativity here. None, either, both. Straight away I eliminated these two, because if I put this, it gives a positive meaning. I am looking for the negative. So none is a short form of no one. No one, none. Neither, not either. So when I am talking about two, the obvious choice is this, not this. If it is more than two, I would go for it. So answer is D. Which one of the following is correct with respect to grammar and usage? Obviously, look at this, guys. Ladakh is more colder than Kashmir, and you have a clue here. Than, obviously, we need a comparative form, and you have comparative form, but look at this one. This is called double comparative, which is obviously wrong. Okay, colder is enough. I don't need more here. That's the reason, gone. Kashmir is not so cold as Ladakh. Okay, we call it as equality, inequality. Yes. Kashmir is less colder. Again, double comparative. Ladakh is cold compared to Kashmir, and the wrong degree of comparison. Colder should be there. So, Kashmir is not so cold as Ladakh. Generally, guys, you might have observed as positive degree as. Suppose if I want to say in another way, Kashmir is as cold as Ladakh. If you want to say equality, here only focus on the grammatical part. If it is inequality, yes, you say so positive degree as not. This structure is accepted. If it is equality, you say as positive degree as. If it is inequality like this, not so positive degree as. That's the right construction, it's right. Fine. Which of the following pairs that best expresses relationship similar to that expressed in the main pair? Analogy. Okay. So, correct is to error, whereas you need to find out. Analogy is about finding out the relationship between this word and this word. Now, if you observe, now my technique is, guys, you try and put a verb here or make a kind of statement. Errors can be corrected or error is corrected. That's a sentence I frame, and I see that kind of relationship, correction or this. Now, assistance is lobbied. Lobbying is a kind of influencing someone unofficially to get the things done, and assistance is lobbying, kind of, going with that. Now, here error can be corrected. Little bit of opposite idea is there. Appearances are decorated. Okay, fine. Appearances are decorated is again a positive effect. We don't find this kind of relation. Errors can be corrected so that it gets better. Appearances are decorated. Oh, it's maybe better. We'll see. Conviction is affirmed as a belief, and it is affirmed. And sin is expiated. Expiate means we call it as atonement. Kind of, what do you say, prashchit. Okay. So, kind of mistake and correction, right? Whereas here appearance decorated, it is like enhancing that. Whereas here errors are corrected. Like that, sin is expiated. As I said, prayashchit. So this is the right one. Fine. Look at this one, jumbled sentences. In the following item, the passage consists of 6 sentences, okay? The first sentence S1 and the 6th sentence S6 are given in the beginning. The middle 4 sentences have been removed and jumbled up. These are labeled P, Q, R and S. You are required to find out the correct sequence of the 4 sentences and mark accordingly. Agreed. First read the S1. Today, the Earth has many satellites besides the moon. Okay. Once again, today the Earth has many satellites besides the moon. That is the beginning of the sentence. Now go through the options, P, Q, R. But the pull of the Earth keeps them from doing so. Whenever I go for the other idea, I always see the link. It can be the extension of that, it can be opposite of that, or it can be explanation of that. Some kind of link should be there between these 2 sentences. So here I don't really see any idea linked here, isn't it? But the pull of the Earth keeps them from doing so. Fine. Next, the artificial satellites do not fall because they are going too fast to do so. He just mentioned satellites, but no mention of artificial satellites anywhere here in the first one. So I go ahead. They are artificial satellites made by man and very much smaller than the man. Next, as they speed along, they tend to go straight off into space. Okay, now I think you got it. Today, the Earth has many satellites besides the moon. So he's talking about satellites, many satellites. Then, they are artificial satellites made by man and very much smaller than the man. Immediately, he is talking about they. They refers to, many satellites besides the moon. So, immediately we know are. So, here this is examination point of view. You don't have to really go through all the sentences first. Find out the options where I have R in the beginning. P, Q, R, S. I think work is done. You don't have to really, rack your brain. This one. I don't have any other option where it is competing with this. R, Q, S, P. They are artificial satellites made by man and very much smaller than the man. Q. Where's Q? The artificial satellites do not fall because they are going too fast to do so. There's a link still talking about, then that's the extension of that. And S. Where's S? P, Q, or S. As they speed along, they tend to go straight off into the space. Yes, there is a link between the not falling and the speed. And P. But the pull of the Earth keeps them from doing so. I think it is pretty straight, easier one. So, answer is C. Thank you.